Hello everyone, a very good morning to all of you. First and foremost, please give me a confirmation if audio and video are working fine. Great, perfect. So I'll just wait for 10-20 more seconds. I see that some of you are still joining. So just give me 10-20 seconds. All right. So let's begin with our session today. Yesterday we had begun with the chapter of energy, and there we first defined what energy is. We had a discussion about what is renewable, what is non-renewable, and so on. And then we had moved to our first section, that is of all the conventional energy sources. And this is where we had started with coal, correct? So we started with coal, and in coal we understood what exactly coal is, we understood how exactly coal was formed, etc. Now we come to the problems that we have with coal, and this is where we discuss about coal ash. Now if you see the screen, there are two things that you see here, two kinds of images that you see, and both are different types of they both are different types of ash. So first one is called as fly ash. This is called as fly ash, and the second one, this one is called as bottom ash. So these are two types of ashes. These are two types of coal ash. Now, when we look at coal ash is one of the biggest challenges that we have when it comes to the generation of electricity. Because when generation of electricity is done with coal, it's basically done with the help of combustion of coal, right? That coal will be burnt, and with the help of combustion of coal, the heat energy that is produced from there, that heat energy is used for generation of electricity, correct? This is how we go. Now, in this particular scenario, what we see is that while the combustion of coal happens, we know that mostly we would be using bituminous coal or sometimes also lignite. Now, in these kind of cases, obviously, because the carbon content is somewhere around 50 to 60, 70%, the rest of the things are impurities, which basically amount to ash, the leftovers after the combustion is completed. So this leftover is also a big challenge for us, and this becomes a challenge mainly because of the fact that this is where you have a lot of impurities that are very harmful for our health and also for the environment. So from that perspective, when we look at coal ash, especially when it comes to fly ash, is a very big challenge, because fly ash is very, as you can see, it's a very fine powder, so it's very light in weight, and because it's very light in weight, it very easily can also escape from the smokestacks of the chimneys. So from there on, what happens is that we see that a lot of it can just simply escape from there, mix with the air nearby, mix with uh, go and settle down in water bodies nearby, the land nearby. So in all these cases, this is something that we see could happen. Now, because of this fact, what we see is that we have to ensure that we are able to either recycle coal ash, or especially this fly ash, either recycle it or dispose it well. So we have some certain methods that we use so that we can dispose of or we can recycle them. On the other hand, the second one, as you see, is bottom ash, which is a much more bigger chunks of particles and much more coarse material, because of which settles down. So instead of it just going out of the furnace, it would just settle out to at the bottom of the furnace. So from there on, collecting it is easy, and hence when it comes to recycling or disposal of bottom ash, it's easier. So that's why bottom ash is not a big challenge for us. But when it comes to fly ash specifically, fly ash is a big challenge. So when we talk about coal ash, this is basically the residues over after the combustion of coal is completed. And after this, in coal fired power plants, basically the thermal power plants, I'm just writing it here. Right, thermal power plants. Now, when it comes to ash, one of the problems that has is that there are a lot of impurities, lot of heavy metals, etc. as well, that can cause trouble for health and the environment. And that's why we see that, especially when it comes to fly ash, we always look towards the problems that we face with fly ash. Now, so when you look at fly ash is a fine powdery silica material created when fine coal or pulverized coal is burned. Then after that, we discussed that there is bottom ash. So bottom ash is much, sorry, spelling mistake, Coarse, coarse ash particle that forms at the bottom of the coal furnace. And because it is, these are larger particles, obviously they settle down, it's easier to take them out from there. Apart from that, we also see that there are smaller parts of this ash as well. You have boiler slag and we have flue gas desulfurization material. So when it comes to, which is more or less in the molten state, all right, it is molten state or partially fused ash, and it is made of certain things like silicon dioxide, it could have aluminium oxide, iron oxide, and calcium oxides. So overall it would have a glassy appearance, and usually we'll see that it will be dark gray in color or might look like crystalline form, or it can be in the molten form. And then after that we have flue gas desulfurization material. So this is something, I think there was a problem with the audio and video, as many of you have written. Is it fine now? Can you just confirm it's fine? And can you confirm where it got stuck? I mean, what was I saying? After which should I explain back? Can you tell me where should I restart from? So from flue gas. Okay. So let me just. Okay. So this slide. Some of you are saying that this slide I should re-explain. All right. So just to recap, we basically discussed that there are two major types of ash. One is fly ash and the second one is bottom ash. The bigger challenge for us, the biggest challenge rather, is fly ash. Bottom ash is easier to handle because it just settles down at the bottom of the furnace. So it can be removed from there very easily, and then we can get rid of it. But when it comes to the other, for example, we have boiler slag and flue gas desulfurization material. These are not big challenges for us. These are uh, there in very small quantity, and that too these are in molten or crystalline state, so it's easier to remove them. All right, it's easier to remove them. So first is boiler slag. So boiler slag also, you can say that in a manner it is a kind of bottom ash itself, where what we see is that this is in either the molten state or partially fused state. Now in this scenario, when it comes to boiler slag, it has various different types of oxides. For example, it has silicon dioxide, it could have aluminium dioxide, sorry, aluminium oxide, it could have iron oxide, and also calcium oxides. So all these could be there, and it would have a dark gray color or a blackish color, as we had seen in this picture. So we'll see that in this bottom ash only, this boiler slag will be many a times also mixed with along with the bottom ash. And then lastly, we have flue gas desulfurization material. So when it comes to flue gas desulfurization material, this is something that is produced when we try the desulfurization, meaning that whenever combustion happens, combustion of coal also leads to emission of a lot of sulfur dioxide. And you might know this, I'm very sure, that sulfur dioxide also is a very challenging pollutant, right? Air, it is also a very challenging air pollutant. So that's why we need to get rid of sulfur dioxide as well. So that treatment that we do, that treatment leads to the production of flue gas desulfurization material. So that's why this is the material that is left over from the removal of sulfur dioxide. And in this scenario, what we see is that it would also have different types of sulfates. All right, it could have different types of sulfates. For example, it could have calcium sulfate uh, dihydrate, sorry, which is also called as gypsum. So in all these kind of cases, we see that all these are problems. But as I told you, the biggest challenge for us is the disposal and recycling of fly ash. Now, in case of fly ash, what we do is, first and foremost, if we want to dispose it, Disposal, there are two different ways in which disposal is done. Either we do it through landfill, that we will dig up land there, uh, this fly ash will be kept there, and then we will cover it up. So that is one of the ways in which we try to dispose it of. The second way to dispose it is in the abandoned mines, the mines where mining activities already have been done, where no more coal mining activities are done. In all these kind of mines, we see that many a times fly ash or even bottom ash, etc., they'll all be kept in these kind of mines. So that's the way in which we try to dispose. But then after that, there are also ways in which we can recycle them. So when it comes to the recycling of coal ash or especially fly ash, we see that there are various different things specially related to infrastructure where they can be used. For example, they can be used to mix with cement. They can be mixed with cement. They can be mixed with in the roads, in road making, the hot mix can also have fly ash, or also in the bricks. So you might have seen these kind of bricks, that there are two kinds of bricks that you might have seen, one the reddish one and then this gray one. So this gray one basically has fly ash mixed in it, and that's why it has this kind of an appearance. So in all these cases, we see that there are multiple different ways in which we can recycle this fly ash. Now, there is one topic, and this I will say is a very, very important topic also from the perspective of your current affairs. Also from current affairs perspective, because last couple of years, we see that coal gasification strategy is something that the government of India has been stressing a lot upon. So what exactly do we mean by coal gasification? We'll try to understand this, and also some of the things related to coal gasification, the advantages that we have with coal gasification, we'll try to understand that. And that's the reason why we are trying to move towards coal gasification. So first and foremost, what do we mean by coal gasification? Coal gasification, as the name suggests, it's gasification, meaning that we are trying to convert it into gas. What kind of gas? This is something which is also called as synthesis gas. Synthesis gas, also called as syngas, or also called as synthetic gas. In some sources, I have seen that they have also written it as synthetic gas. For example, even in the annual report that was published last year by the Ministry of Coal, there also they have mentioned synthetic gas at certain places. So that's why synthesis gas, syngas, synthetic gas, they all have the same meaning, that we are talking about what is made when the combustion of coal is done or coal is heated under certain conditions. Now here, what we get is a mixture of hydrogen, carbon monoxide, and carbon dioxide, where we see that hydrogen and carbon monoxide, they are in higher quantity, carbon dioxide will be in lower quantity. All right, so these two, they will be in higher quantity, whereas carbon dioxide will be in lower quantity. Will be in lower quantity. All right, so this is basically how we see that coal gasification is nothing but when we heat up coal under certain conditions, which leads to the formation of this syngas. Now, when it comes to this syngas, the production of syngas happens at very high pressure, that there will be a high pressure vessel that will have, and the temperature that we will reach will be approximately between 1200 to 1500 degrees Celsius. Normally, the combustion that happens, for example, in the coal-fired thermal power plants, in the thermal power plants, the temperatures that we reach is 300 to 400 degrees Celsius and so on. But here we see that the temperature that we are trying to reach is between 1200 to 1500 degrees Celsius. So at this high temperature and high pressure, we see that under these conditions, in the presence of steam and oxygen, this conversion of coal into syngas is done. Now, in this particular scenario, what we see is that when it comes to this syngas, there are various different ways in which syngas becomes advantageous for us. So, why syngas? Why are we talking about this syngas? What we saw was that in the budget last to last year, in 2021 budget, for the first time, the government of India basically talked about coal gasification strategies, and how government of India wants to use coal gasification for generation of electricity, that going forward, instead of using the coal-fired thermal power plants, they want to switch to this. They want to switch to coal gasification strategy. In this coal gasification, why they do want to shift is because of certain advantages that we see. So, for example, the burning is cleaner. What we see is that when it comes to coal gasification, coal gasification has lower amount of emissions as compared to the normal combustion of coal, and that's why, especially when it comes to pollutants like sulfur dioxide, nitrogen oxides, and particulate matter like PM 2.5 and PM 10, these kind of pollutants are pretty less in case of coal gasification as compared to the normal combustion of coal. So that is one thing, that it has much cleaner burning, so the effect that it might have on the environment will be far lesser as compared to the normal combustion. Then the efficiency is great. What we see is that the conversion can be up to 95% of the energy. Whereas when we talk about the normal combustion, I'm just writing here, normal combustion, this shows approximately somewhere around 33% efficiency. So efficiency wise also uh, it can be much greater. All right, efficiency wise also it can be much greater. So that's why we see that in these kind of cases, coal gasification strategy can help in better conversion, better efficiency, and that's why we see that it will have an advantage from that perspective as well. Then we see that it is also versatile. Why we are calling it as versatile is because there are different ways in which this coal gasification can be used, or this syngas can be used. Syngas is something that is not only useful for thermal power plants, but at the same time manufacturing of various chemicals as well, it can be used. For example, the manufacturing of fertilizers, a lot of fertilizer manufacturing plants, they also make the use of syngas. All right, so that's why it can be used in electricity generation, in heating, and the production of chemicals and other products, especially, or one example can be fertilizers. And depending on the industry, we see that there are different types of classification of syngas also that we do. I don't think that's required for your exam, but there is water gas, there is producer gas, there is coal gas. So there are all these kinds of gases which are basically syngas in various different you can say combinations. That in some cases carbon dioxide will be little more, in some cases carbon monoxide will be little more. So in some cases hydrogen. Then from here on, we can this can also lead to the production of hydrogen. So when we talk about the various different types of hydrogen, in that we also talk about gray hydrogen. And in this case of gray hydrogen or even black hydrogen, this is where from coal you are trying to produce hydrogen. Right now in the news we have green hydrogen, right? Green hydrogen has been in the news, and last year especially green hydrogen was pretty much in the news. And that's why in this year's prelims examination there were two questions that were asked from green hydrogen. Similarly, there are other types of hydrogen like brown hydrogen or gray hydrogen, black hydrogen, pink hydrogen, yellow hydrogen, depending on what is the source of hydrogen. So when the source of hydrogen is either coal or let's say syngas, then in that case they can be called as black or gray hydrogen. So in this manner we see that there are multiple different ways in which we can make the use of syngas. So overall, what we see is that it might also help us in enhancing our energy security, because our efficiency levels will be much better. And with better efficiency levels, we'll obviously be able to get more energy out of coal as compared to what we are getting, and that too cleaner energy as compared to what we are getting. So that's why these are certain advantages that coal gasification has, because of which we have seen that a lot of emphasis is being put by the government of India on coal gasification. That the Ministry of Coal also keeps talking about coal gasification and what India wants to do. And even if you look at the last year's end of year report by Ministry of Coal, there also they had mentioned everything in a pretty elaborate manner. So but that's not required, because that was a completely industrial discussion that they have done in the year end document. I don't think that's required for you, but these are some of the basics that you should know about coal gasification. All right, so let's try to solve this question. Look at this question, read this question, and then I launch the poll for you. I hope you have read the question. I'm launching the poll for you. Wonderful. 71% of you have marked A, which is the correct answer, 8% B, 17% C, and 4% D. All right. So let's look at the question. With reference to fly ash produced by power plants using coal as fuel, which of the following statements is or are correct? First, fly ash can be used in the production of bricks for building construction. We discussed this, right? We saw the picture of the bricks as well. So yes, it can be used. So one is definitely correct. So B and D should never have been marked because this is the easiest option, I believe, here. Second is fly ash can be used as replacement for some of the Portland cement content of the concrete. This is also correct. We discussed that it can be mixed with cement. So yes, Portland cement, it is always mixed with. Third is fly ash is made up of silicon dioxide and calcium oxide only and does not contain any toxic element. The entire discussion that we are doing is because it has a lot of toxic elements. So we can't really say that it does not have any toxic elements. So three again, it's a very easy answer not to mark, correct? Because we know that the entire discussion was about the problems, right? The toxicity, that you have cadmium, you have uranium, you have arsenic, you have lead, you have mercury, and then you have the leftover residue that can lead to PM 2.5 and PM 10 particulate matter. So there are all these problems. So of course, we cannot say that there is no, does not contain any toxic element. Of course not. This is wrong. And also remember that it has words like only. Wherever you see these kind of words, mark it. Just remember that these are some extreme words, and we look at a lot of questions where you'll find these extreme words, and more often than not, I mean, let's say 9 out of 10 cases, if not more, you'll find that extreme words are wrong. Wherever they use extreme words, they more often than not are wrong. Can you think of what are extreme words? What for you is an extreme word? Anything that has a very absolute meaning. All right, anything that has a very absolute meaning will be called as an extreme word. So can you suggest certain things? Yes, only, any, always, correct, all, no, drastically, never, entire, correct, absolute. So right, so I'll mention this. There are so many things so that it will also help others. So you understand the meaning, correct? So let's say things like always, none, right, every, all, entire. So all these things, just understand. So wherever you have any, sorry, I missed such an important one, any. So in all these cases, just understand that. All right, so in all these cases, just understand that this is something that will be very very important for you to mark something, or at least if not wrong, just read it twice or thrice, just to ensure that you know that this should not have used an extreme word. All right, so yeah, so never also, as many of you have mentioned. So let me write here, Never, because it's actually a very often used word. Never. Right? So in all these cases, just understand this, that wherever you have these kind of extreme words, most of the times these answers are wrong. I mean, these statements are wrong. Right. So next, moving on to petroleum. Now, in case of petroleum, also we know that petroleum kind of runs the economy right now. Correct. Whether Indian economy or world economy, we know the importance of petroleum, how it helps as a fuel. It acts as a fuel, and it has been the fuel on which the economy of the world runs. Petroleum also is a fossil fuel, just like coal. It might also have been formed approximately 250 million years back. So overall, these are similarities. But when it comes to the chemistry of coal versus chemistry of petroleum, they are very, very different. So just understand these things, that how do we compare between petroleum and coal? How do we compare between them? So first and foremost, let's say, uh, from the perspective of, let's say, their composition. If we talk about their composition, so composition wise, what we know of coal is that coal is made of carbon, right? Carbon plus maybe there are some impurities that you have, but nothing else. It has just carbon. Now in case of petroleum we say that it's a complex mixture of hydrocarbons. So that's the first difference, that their composition itself is different. Then from the perspective of their origin, so for coal, what we discussed is that the origin would have been in the wetland areas, correct? The origin would have been in the wetland areas, in the wetlands. And in case of petroleum, when it comes to the origin of petroleum origin would have been underwater. The formation would have become would have begun underwater, largely seas and oceans. So even the formation could have happened in lakes also. It's not that lake formation does not happen, but largely under seas and oceans, the origin would be. Then the source. So we discussed about coal, that coal is nothing but prehistoric vegetation. Prehistoric vegetation of wetlands, correct? And in case of petroleum, the larger source could have been algae and zooplanktons. Now, algae, of course, are plant-based. Zooplanktons are animal-based. So that's why, in case of coal, coal is basically plant-based, and petroleum could be both plant and animal-based. All right. So that's why, in simpler terms, coal is veg and petroleum is non-veg. So that's why for non-vegetarians, I could say that don't consume petroleum. For the vegetarians, I could say that consume coal, but obviously you can't consume coal. But so this is where the difference lies between coal and petroleum. Now, from the perspective of some of the things that are common, we know that both are fossil fuels, right? We know that both are fossil fuels. And why fossil fuel? Because they have taken almost more than 250 million years in case of petroleum, and more than 300 million years in case of coal. All right. So both are fossil fuels. Secondly, biggest source of energy currently, biggest energy source currently for the world. And third, highly polluting, highly polluting and contribute to global warming. Contribute to global warming. So we understand that there are certain similarities and there are certain differences. So difference basically is in their composition, in their structure, in their chemistry, right? And so when we look at petroleum, what we say is that it's a complex mixture of hydrocarbons that occur in the earth in liquid, gaseous, or solid form. Liquid, gaseous, or solid form. So in a manner, you can say that this is another difference between coal and petroleum, that coal is in solid state, correct? And in case of petroleum, it could be gaseous, it could be liquid, it could be a solid. Although we are used to looking at the liquid form of petroleum, which is petrol or diesel or kerosene, etc., or crude oil in general. But just remember that petroleum does not really mean only the liquid form, but it can also have the solid, or it could also have the gaseous form. Now, in case of this, what we are saying is it's a complex mixture of hydrocarbons. So, what do we mean by hydrocarbons? So, when we say hydrocarbons, again, there are two words. So, in a manner, you can say that they are a mixture of hydrogen and carbon. All right, they are a mixture of hydrogen and carbon. So, when you have any compound which has only hydrogen and carbon, then in that case, we say that these are hydrocarbons. There should not be any third material. So, that's why when we say that they are made of carbon and hydrogen only. So this time, if let's say a statement comes, this only will be correct. That when you have only carbon and only hydrogen in any compound, you say that it is a hydrocarbon. And there are multiple different kinds of hydrocarbons. Uh, some of you may have heard of it. You have alkanes, you have alkenes, you have alkynes, you have cycloalkanes. So there are multiple different types of hydrocarbons, but the key thing is that when it comes to hydrocarbons, it is made of only hydrogen and carbon. Now, what we are saying is that this is a complex mixture of hydrocarbons. So when we say complex mixture of hydrocarbons, we know that when it comes to a mixture cannot be assigned a chemical formula, correct? There is no chemical formula for a given mixture. It has to be a compound or an element to have a chemical formula, right? So in a molecule of element, or let's say a compound altogether, will have its chemical formula, but otherwise for mixtures there are no chemical formula, because there is no fixed ratio. All right, because there is no fixed ratio between how many molecules of this hydrocarbon versus how many molecules of that hydrocarbon, and so on. So that's why we say that it's a complex mixture. For example, let's say in case of petrol, so petrol is a mixture. It would have various different types of hydrocarbons. It can have octane, it can have octene, it could have heptane, heptene, nonane, nonene, nonine. So there are multiple different types of hydrocarbons that could be present as a mixture in petrol. All right. So there is no fixed ratio, and hence we do not give it any chemical formula. So for example, the picture that you see here is of a cycloalkane called as benzene, right? So this is a picture of benzene, which is also a hydrocarbon. So in all these cases, what we understand is that in all these cases, what we see is that these are hydrocarbons. Now, when it comes to petroleum formation, the formation process here also is pretty similar as compared to what we have discussed in coal. That the formation again, this time instead of wetlands, this time the formation would have begun inside water, underwater. And in these underwater conditions, again something similar would have happened, that these plants and animals, algae and the zooplanktons, they might have gotten buried under the deep ocean surfaces and sea surfaces, and while getting submerged, they again got mixed with the sediments there, subjected to high temperature and pressure. Under these conditions of high temperature and pressure, first there is an organic conversion that happens into something called as a kerogen. First, an organic combustion happens, sorry, first an organic conversion happens into kerogen, and then after that we see that there are multiple different processes. The next process after that is catagenesis, and then lastly we see that there is a process of pyrolysis. So just understand how exactly things work here. So let's say first we start with the algae and the zooplanktons, right? We have the algae and the zooplanktons. So we have algae and zooplanktons. They basically they are submerged, right? They get and submerged and mix with sediments. All right, they get submerged under the sea surface. So this basically exerts high temperature and pressure. High temperature and pressure. And after this, what we see is that as they are subjected to high temperature and pressure, this is where what we see is that they first convert into something which is an organic form, a sedimentary form, which is called as kerogen. All right, first converted into kerogen. So basically when it comes to kerogen is, you can see in a manner, a kind of, this is a kind of sedimentary rocks. So kerogen is formed, and after the formation of kerogen, what we see is that this now is an organic form. Basically, the plant or the animal now has converted, and this has converted into an organic form, like a stone, basically, you can say. Now, from here on, what we see is that from kerogen, the next step is called as catagenesis. The next step is catagenesis. So, next step is catagenesis. Now, catagenesis basically is when the long hydrocarbon chains, they break down into smaller chains. So basically what happens is that in the organic form or in the kerogen form, the hydrocarbons that you have, the chain of hydrocarbons that you have, this chain of hydrocarbons is very long. So for example, it might have 80 or even 100 carbon atoms in the chain of hydrocarbons. All right. So now what happens is that it breaks down into smaller chunks of, let's say, 10, 20 carbon atoms, etc. So they break down into smaller chunks. Now when they break down, so this is called as catagenesis. So this is breaking of large carbon chains into smaller ones. Right? Breaking of large carbon chains into smaller ones is called as catagenesis. And then once catagenesis has happened, then comes the last process, which is called as pyrolysis. Pyrolysis. Now, in case of pyrolysis, what we see is pyrolysis basically is a process where chemical decomposition of any material happens under high temperature and high pressure in the absence of oxygen. All right. So when thermochemical decomposition of a material happens at high temperature and high pressure in the absence of oxygen, we say that it is pyrolysis. So next, last process is pyrolysis. So what is pyrolysis? This is thermochemical decomposition of material at high temperature and pressure in the absence of oxygen. All right, so this is basically how it works. This is basically how it works, that we the that ultimately with pyrolysis we see that it would have converted into a form of petroleum. So ultimately we see that this is the process of formation. So formation process wise, it's not very difficult, I mean, sorry, not very different from what we see with coal, principally more or less the same. But these kind of things like pyrolysis or the formation of kerosene, etc., we see that the process there is simpler as compared to here. So now next we have to understand something called as fractional distillation. Now, the petroleum that we get now, the petroleum that we get after these processes, this petroleum is basically, you can say that this petroleum is a mixture of different types of petroleum products. So, for example, this petroleum that we now have, this petroleum might have petrol, it might have diesel, it might have kerosene, it might have paraffin. All these things will be mixed together. So this mixture is not useful for us. So then there is a process called as fractional distillation, which is used so that we can uh, get all the different types of petroleum, that is, or various different types of petroleum products that are mixed together. So to get all these different products, or to get all these different, something called as fractions, to get all these different fractions, we do the process of fractional distillation. All right, we take uh, use the process of fractional distillation. So understand two things. First and foremost, what do we mean by distillation and what do we mean by fractional distillation? So first and foremost, if I ask you, do you know when do we use distillation? Can you tell me when do we use distillation as a process? Hmm. So separation. Hmm. So Madhur, your answer is correct. Rakshit, your answer is correct. So yeah, separation. Many of you have written that for separation we use distillation. But what kind of separation? When can we use distillation? So basic principle of distillation is, all right. Basic. Just understand this, that the basic uh, use of distillation is that when you have two miscible liquids, all right, when you have two miscible, let's say fluids, you have two miscible fluids or liquids which have sufficient difference between their boiling points. All right, so for example, let's say you have a mixture of two liquids, one say is water and one is an organic liquid. So this organic liquid, it boils at 50 degrees Celsius and water boils at 100 degrees Celsius, and they are mixed together. Many of the organic liquids, they can very easily mix in water. So now because they mix in water, what we see is that there is a difference in their uh, boiling point. So many of the organic liquids, for example, let's say uh, from my friends I've heard that there is something called as alcohol which mixes very well in water. So this alcohol and water mixture is something that can be separated with distillation if you want. So otherwise they would have mixed very easily, and once they have mixed, you cannot separate them out. It's not like oil and water, which can be, where we see that oil basically forms a layer on water because of the difference in density. But here what we see is that organic liquids especially, they can mix very easily in water. You might have also heard that there is something called as alcohol that can mix very easily in water, right? So in that case, what happens is that alcohols would generally have lower boiling point, and compared to that, water would have much higher boiling point. So in that case, these two can be used, I mean these two can be separated with the help of distillation. So distillation basically is used in separating out two miscible liquids with sufficient difference in their boiling points. Just remember this. All right. So the basic principle of distillation is that different liquids boil and evaporate at different temperatures. So this is how we use distillation. Now then, how is fractional distillation different from distillation? Because in case of distillation, we understand that fine, when you have two liquids or two fluids which can mix in one another very easily, cannot be separated out in their physical form, then in that case, we use the process of distillation. Now in process, what we do is very simple, that you take that mixture, let's say the mixture is at room temperature. So for example, let's say organic liquid in water. So this mixture is at room temperature, let's say 25 30 degrees Celsius, and then you start heating it. So as you start heating it, when it reaches, let's say 50 55 degrees Celsius, or let's say 60 65 degrees Celsius, you'll see that this organic liquid will start to boil, because its boiling point is near about 55 to 60 degrees Celsius. But water would have just become warm, right? Water would have just become warm because water boils at 100 degrees Celsius, correct? Water boils at 100 degrees Celsius. So when you are, let's say, are at 75 degrees Celsius, organic liquid would have completely converted into its gaseous form, whereas water would still remain in its liquid form, right? So that's why we can very easily separate these two. And the gaseous form of this organic liquid that we are collecting, this can be collected and can be cooled down so that you can collect it in another vessel. So in this manner, water and this organic liquid can be easily separated. Now, compared to this normal process of distillation, where you simply uh, heat the mixture, in case of fractional distillation, that direct heating does not work. So fractional distillation is something that we use when there is not sufficient difference between the boiling points. So for example, when the difference between the boiling points between uh, m- uh, between boiling points, let's say this is just around 10 degrees Celsius, or maybe 15 20 degrees Celsius, up to let's say 25 degrees Celsius. So if the boiling point difference is low, then the normal heating process does not work. Then in that case, we use fractional distillation. And in case of fractional distillation, what we see is that first we would heat the entire mixture to a very high temperature, a temperature where all this mixture will be in its gaseous form. And then we start to cool it down separately. Then we start to cool it down. Then we start to uh, then we start to very slowly cool it, so that as it starts to reach the temperature of boiling points of each and every part of the mixture, you will start getting them in their liquid form. So this is basically what we do. So when you look at this, so first and foremost, in case of crude oil, this will be heated to a very high temperature. All right, heated to a very high temperature, and then after that, slowly and steadily, we keep on cooling it. And as we keep on cooling it, we see that the temperature keeps on decreasing. Temperature keeps on temperature obviously decreases. We see that all the different fractions is something that we keep getting. So ultimately, first lubricating oil or paraffin, wax, asphalt, etc. will get, and then after that, fuel oil, diesel, kerosene, petrol, and lastly the gaseous forms like butane and propane. So in this manner, we see that fractional distillation will be helpful. So when do we use fractional distillation? It is used when the difference in boiling points of the mixture components, difference in boiling points of mixture components is not very high, usually less than 25 degrees Celsius. All right, When the difference is less than 25 degrees Celsius, then in that case fractional distillation is used. So in case of fractional distillation, what we see is that first, what is the process? What is the process? That first the mixture is heated to a temperature where the entire mixture is in gaseous state. Then it is cooled slowly to obtain the various components, are also called as fractions of the mixture. So this is basically how we go with fractional distillation. All right. So this is what happens with fractional distillation, and ultimately we are able to get the required result. Now, apart from coal and petroleum, one of the major unconventional source has been shale gas. So this is basically something that refers to the natural gas that is trapped within the shale rock formations deep underground. So if you look at this, uh, you might find that when it comes to shale gas would probably be found even lower as compared to oil and gas. Even as compared to oil and gas, it might be at a lower stage. So as you can see that this is a layer of shale rocks, and in this layer of shale rocks the shale gas is trapped. So to get this shale gas, what we do is that we dig a horizontal well. First we'll go to this layer, and after reaching this layer of rocks, we start drilling horizontally. All right, we start drilling horizontally, and then after that there is something, what we do is next is that there is hydraulic pressure that is applied here. Basically, water at very high pressure will be sent through this well, and with the help of this water, the pressure that is created, this will create some cracks. All right, it will create some cracks, and these cracks are through which this shale gas will be taken out. So shale gas will be emitted because of these cracks, and this shale gas then will be taken to the surface, and then it can be used as a source. So in this manner we see that shale gas in this manner can be found. So largely when it comes to shale gas, right now if you look at the world distribution, you'll find that US has been one of the leading countries, China has been one of the leading countries. There are others, for example, Australia has a good significant amount. Argentina is a very, very big player in these kind of cases. So and also Russia. So in these are some of the countries which have good sources of shale presence. Now shale has been very, very crucial. Shale has been crucial especially for the US economy. Shale has been a game changer, if I may say so. And why I say that it has been a game changer: before the discovery of shale, before US discovered shale, US was a net importer of energy. That US was not able to cater to the needs of the country with the help of all the resources that it had, with all the production of energy that was happening in the US. They were not able to support everything. So they used to import energy. They would import petroleum, they would import coal, and so on. So they were a net importer of energy. And what we see is that after the discovery of shale, they became a net exporter of energy. So the scenario for them, the economic scenario for them changed so drastically that first they were buying and now they started selling. So So that's why what we see is that the formation of shale, which is basically natural gas and nothing else, natural gas, that is methane, plus mixture of some of the other hydrocarbons, but largely it is methane, largely it is natural gas. So what we see is that shale, from here on, it can be extracted. So first, US found large deposits of shale, and as I told you that their economy basically changed after they found it. And then a natural justice was done, that even Russia found it. So that's why, and it was the Cold War era, so both of the parties having this resource meant that there will be peace in the world. So, but then there are other countries. Now China also, we see that it's a big player. Argentina also has a good amount of shale deposit. So we see that there are all these things. Now coming to India, where we look at what we have as our shale resources. So all these areas marked in indigo, you can say, this blue colored part, these are the ones where we already have found shale presence. These are the areas where in India shale presence is there, and the others where you have this orange colored areas, these are the potential sites. These are the potential sites where we find that there are chances of finding shale in India. Now the problem with shale in India is, and this map was released by ONGC. Now ONGC between 2011 to 2021, between 2011 to 2021, was surveying all these sites, was surveying the entire country to understand whether we have a source of shale that is precisely usable. But after almost 10 years of research, 10 years of looking at the various sites, ONGC ultimately said that we probably cannot make the use of shale, because the shale presence, even though we have shale presence in India, but they are not commercially viable. All right, not commercially viable. So shale resources in India, they said that they are not commercially viable. It means that you basically are spending a lot of money to get a very small amount of energy. So that doesn't help, that you are spending more energy and you are gaining less energy out of it, then that process should not be used. Correct. So and even if, let's say, there is a marginal profit, or there is a marginal extra electricity that you're producing, even that is not enough. So that's why in all these cases, ONGC said that although we do have resources and we'll keep looking for resources, but at this moment, whatever we have seen, we don't really see a lot of uh, that we see that we should not be dependent on this as a source. We cannot think of it as a source, maybe as an additional source in the future, but right now we do not see it as commercially viable. So this is about the shale presence in India. Now when it comes to issues with shale extraction, we see that there are certain problems that we see. For example, there is an increased combustion of fresh water. Now this use of fresh water is largely for providing that hydraulic fracturing that we do. So this basically is used for hydraulic hydraulic fracturing. That for hydraulic fracturing we use fresh water. So a lot of fresh wastage of fresh water also happens. Then there are chances of inducing seismicity or earthquakes. Now why we are saying about this is because ultimately you are going beneath the surface and you're trying to create cracks there, and through these cracks all the gases are being taken out. So in all these cases, especially let's say if these are being done in areas which are along the tectonic lines especially, then in that case there are high chances that it could lead to some kind of instability. So we need to understand that aspect as well. Then there is a potential for ground and surface water contamination, because a lot of this fresh water that you are sending, you also add certain chemicals to it. All right, you add certain chemicals to it, and the addition of these chemicals, they can lead to ground or surface water contamination. And then lastly, there could be local impacts, because these are unconventional sources, these are newer sources as compared to the others. So because of that, it's not that easy for us. All right, it's not that easy that we'll be able to use it so easily. So that also has been one of the challenges that uh, when it comes to, let's say, a new source. For example, let's say any government in the world, it finds a new source of shale. Do you think that after finding shale they'll leave it like that, just thinking that okay, there are people who are going to get impacted and there will be a lot of problems that they will face in the future? I don't even think that any government is going to think that, if they are getting a good source of energy, right? If they are getting a good source of energy, all the priorities will change. They will think of very different ways in which they can resettle people somewhere else. They will look for doing all this just to ensure that they can use the energy source that they have found, correct? But it's almost unthinkable that any government in the world today, given the scenario that we are in, will let go of any new energy source that they find. So that will lead to these kind of local impacts, because movement of machinery, movement of trucks, etc. will happen. So there will be a lot of noise, the pollution levels will start to rise, uh, a lot of air pollution because of dust, etc. will happen. So we'll see that all these will be the local impacts that we might see as a result of shale gas extraction. So that's also one of the problems. Then coming to coal bed methane. Now, coal bed methane specifically now has again become important, largely because now Government of India is looking towards coal bed methane with much more seriousness than before, than we have ever done before. All right. Now, when it comes to coal bed methane, just see this picture. So what you see basically here is that coal bed methane will be found in areas which are near the coal mining sites. Now, the coal mining sites are much more near the surface, near the crust, as compared to shale gas resources or petroleum resources, or even natural gas resources. They are much deeper, right? They are much deeper as compared to coal bed methane. So, coal bed methane is nothing but methane that is found in the coal beds, meaning that methane that you find in the areas that are adjacent to coal mines, which are near coal mines. So that basically is called as coal bed methane. So what we see is that coal bed methane becomes a very, very crucial uh, way in which we can find new sources of methane, which ultimately is natural gas. So you can say that it is an unconventional source of natural gas. So it is, just remember these names also, that these are also known as coal seam gases or coal mine methane, a type of natural gas that is found in the coal deposits, near the coal deposits. So when it comes to India, for example, we have seen that there are sites that have been marked where we have potential coal bed methane. So all the areas that you see which are marked in yellow, all the areas that are marked in yellow, as you can see that these are areas which are very near to the sites of bituminous coal or lignite, and these are the areas from where there are chances that we'll be able to extract methane. And if that methane can be extracted, this will be called as coal bed methane. So what we see is that there is a change in the policy, that now they are trying to focus upon these resources. They are trying to focus upon coal bed methane, because right now government of India, or let's say for that matter other governments across the world, they are looking for new sources of energy, alternate sources of energy, as much as they can. They're always looking for these sources of energy, because they also understand the value that everybody has been trying to move away from coal and petroleum. In all these cases, right now, whatever they can find, whatever new sources they can find, they will try to tap it as much as possible. So now we see that there is uh, a change stance, there is a revised stance that the government of India has towards coal bed methane, which has been missing for a very long time. We see that a lot of coal bed methane in the past has been lost because of lack of any policy or lack of any understanding of coal bed methane, that how exactly we can use coal bed methane. So that is something that we see today. But just remember that, from again, this is a topic for current affairs. This is a current affairs topic, because now there is a renewed interest that the government of India has shown towards coal bed methane. Then after this, we have something called as methane hydrate. Now, methane hydrate is nothing but the hydrate form of methane. Now, what do we mean when I say that it's a hydrate form? What do we mean when we say that it's a hydrate form? So hydrate form means that you have water molecules mixed with it. All right, water molecules. So not exactly liquid. Just understand this. As you can see in the picture also, that it's not exactly liquid. It is in the solid form. So solid form, the crystalline form of water does not always mean ice. Even at room temperature, there can be solid form of water or crystalline form of water. Can you name some? There are some very commonly used hydrate forms that we use in our daily lives. Can you name some? Okay, so a lot of answers I'm seeing here. Okay, baking soda, plaster of Paris. Yes, plaster of Paris is a good example, right? Plaster of Paris, you have CaSO4 dot I think 5H2O. So plaster of Paris is a good example. Then again, washing soda. What about washing soda or washing powder basically? Can we say that it is also sodium chloride? We cannot. Because sodium chloride is a crystalline form, but not a hydrate form. Yes, it can mix with water. No doubt, it can mix with water, but it becomes moist when it mixes with water. So that's why, in that case, we should not call it as a hydrate form. But most common example I would say is your washing powder, because washing powder is something that already has which already has the crystalline form of water molecules. So just understand that when it comes to the crystalline form of water molecules, uh, they can be present in various different forms, and they all can be not exactly, they are not always in their solid form. So it's not necessary that water molecules will always be liquid above, let's say, 0 degree Celsius, only in their pure form. So for example, let's say if you have water, let's say if you have water, pure form of water, then it will be solid only below 0 degree Celsius. But if it is mixed with something, then, and it is in a hydrate molecule form, then those water molecules can be present, and yet that thing could be in its solid form. All right, so that's why we just understand this. So when we say that it is methane hydrate, methane hydrate means that it is a crystalline form of methane and water mixed together. Now there are various parts of the world where we see that deposits of methane hydrates have been found. So for example, Arctic and the Antarctic ice. Arctic areas and the Antarctic areas, they have been two prime areas where we have found the deposits of methane hydrates. Apart from that, the sedimentary deposits along the continental margins, as you can see in the picture above, that all these areas, the orangish kind of areas, these are the areas, or I mean, for the purist, the peach colored areas. These are the areas which basically have the deposits of methane hydrates. All right, and then apart from that, the deep water sediments of inland lakes and seas. So you have the continental shelf, the continental margins, the deep oceans, the inland seas and oceans, And then apart from that, we have the Arctic and the Antarctic areas. These are the areas where we find the deposits of methane hydrate. All right. So what is methane hydrate? Nothing but a molecule that has methane and water mixed together. Now look at this question, and there is one very important concept that I want to discuss with you through this question. So first, you just read the question. Let us discuss this first, and then after that, I'll tell you. If you've read the question, I'll launch the poll for you. Please mark your answers. All right. So it's a pretty mixed response. 27% A, 19% B, 17% C, and 36% D. All right. So let's discuss this. Which of the following statements are correct about the deposits of methane hydrate? First, global warming might trigger the release of methane gas from these deposits. Global warming might trigger the release of methane gas from these deposits. This is a correct statement. All right, this is a correct statement. So what basically happens is that, especially in the Arctic areas, we have seen this to be a big challenge today for us, that a lot of methane in the form of methane hydrates or even in form of methane, we see that it has been the ice caps, because the polar ice caps, you know that it's a huge deposit of ice that they have. Now these ice layers, they have been melting. Now because of the melting of these ice layers, what we see is that methane that was deep underground, now it has come to the surface because of the melting of the polar ice caps. So instead, because of that, what's happening is that this is releasing more of methane into the atmosphere, releasing more of methane into the atmosphere, which ultimately for us, what it means is that global warming is causing more global warming, because ultimately methane is a greenhouse gas. So if all this methane that was until now trapped under ice, if now this is coming to the surface, then it also simply means that you are basically leading to an accelerated global warming. Correct? It is leading to an accelerated global warming, which is going to be very bad. So that is ultimately something uh, that is happening today. And in all these cases, we see that this is becoming a big challenge. The melting of ice, or what we call as the thawing of ice, what we call as thawing, THAWING. All right, what is called as the thawing of ice or the melting of ice is leading to more methane being released, and this, that's why you can say in a manner, is leading to accelerated global warming. Accelerated global warming. So this is basically what we see, and that's why first statement is correct. Second is, large deposits of methane hydrates are found in the Arctic tundra and under the seafloor. This is correct. We discussed about this, right? We discussed deep water sediments of inland lakes and seas. So that's why, and we discussed about Arctic permafrost as well. So that's why Arctic tundra correct, and under the seafloor also correct. Third is, methane in the atmosphere oxidizes to carbon dioxide after a decade or two. Is this correct or wrong? This is also correct. So what happens ultimately is what ultimately happens here is that this methane, generally speaking, when it comes to methane, in a short period of time it is inert, it does not really react very well or doesn't react easily. But what we then see is that ultimately it does react with oxygen. Ultimately it does react with oxygen, and this forms carbon dioxide and moisture. All right. So if you are also a fan of balancing the equation as I am, so please do this. So then in that case, this is basically what we see. So understand this, that methane in the atmosphere oxidizes to carbon dioxide after a decade or two. Basically what happens is that this methane, that the methane that has been released, the methane that is there in our atmosphere, this methane for a very long time will remain as methane in the atmosphere, but ultimately starts to react. Ultimately it starts to react with oxygen, and when it reacts with oxygen, it forms carbon dioxide. All right, it forms carbon dioxide. And then in this particular case, what we see is that ultimately methane does not exist, it remains as carbon dioxide. It, so for, let's say, for the first 8, 10, 12 years it will exist as methane, and then for the next approximately, let's say, 100 odd years, it will remain there as carbon dioxide. So that's why methane as a greenhouse gas is much more potent, is much more dangerous as compared to carbon dioxide. So in this scenario, this third statement is also correct. So correct answer here will be 1, 2 and 3. Then after that we have HCNG. So HCNG stands for hydrogen enriched compressed natural gas. So hydrogen enriched compressed natural gas, HCNG. So now in case of HCNG, we basically are saying that we are mixing hydrogen to CNG. Now what is CNG? CNG is compressed natural gas. What exactly do we use CNG for? We can use CNG as a fuel. You might have seen that especially in the Delhi NCR region, for the last 20 odd years, we have been using CNG as one of the alternate fuels, and all the auto rickshaws, etc., they run on CNG in Delhi. Now ultimately when it comes to HCNG, we are saying that it combines the advantages of hydrogen and methane. Now understand hydrogen, all right, because today we see that hydrogen has been in the news so much. We have been talking about green hydrogen, we have been talking about hydrogen as fuel, and using hydrogen everywhere, in manufacturing plants, in iron and steel industry, in fertilizer plants, in electricity production, yeah, using it in the cars. Everywhere we are looking to use hydrogen. So what is so special about hydrogen? Let's try to understand this, that why are we looking towards hydrogen so much? There are some basic things that hydrogen shows. There are some basic properties that hydrogen shows. First and foremost, a simple thing, that is about the abundance of hydrogen, right? Abundance of hydrogen. Now why are we talking about abundance of hydrogen? Because when you look at the composition of the earth, you will find that hydrogen is among the top 10 elements on the earth. So forget about the fact that we discussed that 4% of the universe is just hydrogen and helium. That's not usable hydrogen for us, right? We don't go beyond our planet to capture hydrogen. But even earth has a lot of hydrogen, a lot of hydrogen in its elemental form, and also a lot of hydrogen in so many different things. All right. So for example, uh, 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 let's say water. A very simple example, what is water? H2O. So H2O means that it has hydrogen. So water can be used as a source of hydrogen. Similarly, we discussed about so many petroleum and natural gas and so on. All the hydrocarbons have hydrogen, so there also we can get hydrogen from. So ultimately what we see is that hydrogen is present in its elemental as well as its compound form in a lot of things which are very commonly found in the world. So that's why getting hydrogen is easy, or getting the raw material from where hydrogen can be used is easy. So that's why we understand that abundance is a big thing, that hydrogen is abundant. Then very very important, hydrogen is clean. Hydrogen is clean, no carbon dioxide, no nothing. So that also adds to the advantage, right? So that's why, and it's a very simple thing, that because there is no carbon dioxide, of course. So because there is no dioxide, it also means that there will be no emission, there will be no pollution, no air pollution, no climate change, all these things. So that's why hydrogen becomes very very crucial from that perspective. Then after that, one very very important fact about hydrogen is that hydrogen has high energy density. High energy density. So when we say high energy density, you can say that in a manner, it's uh, weight to density, or energy, let's say energy to weight ratio. Energy to weight ratio is very high, and that makes it very very efficient as an energy carrier. All right, as an energy carrier. So that's why it can be used in transportation, it can be used in other activities as well. So that's why this becomes very very crucial, that it has high energy density. I'm writing this, the meaning of it. High energy density meaning that its energy to weight ratio is high, right? Energy to weight ratio is high. So that's why basically it becomes efficient energy carrier. So that also becomes very very crucial. Then apart from that, what we see is that when it comes to the storage of energy, it can be used in various different ways, and hence we are using it here. So ultimately these three, just remember that there are these three very very important point. That first, hydrogen is abundant, so we can use hydrogen in whatever form we want. We can get hydrogen from various different ways. And it is a clean source, non-polluting source, no carbon dioxide, no air pollutants. So that's why it is very very important. And high energy density, meaning that it is highly efficient. So these are the basic advantages that we have with hydrogen, and why we want to mix it with methane to form clean hydrogen, or let's say clean CNG. So the advantages of HCNG will be that first of all, reduces the emission of carbon monoxide, almost we see that almost by 40%. Almost by 40, by approximately, I'm writing approximately, by approximately 40%. Then it will also enable fuel savings, and that's basically about hydrogen, because hydrogen has high energy density. So that's why it is more efficient, and hence it will save more fuel. So this is because of hydrogen. This is because hydrogen's high energy density, or let's say efficiency. Then engines can be calibrated to release lower amounts of nitrogen oxide. Then minimum modification is required to run on HCNG. So if let's say something is switching from CNG to HCNG, then in that case it hardly takes any effort, a lot less effort. So that also is big thing. Otherwise, new fuel generally means a new engine altogether, and that again is very costly. So that's why we see that instead of using that directly, we see that with minimum modification we actually can use HCNG. Then it can be used in high load applications and heavy duty vehicles. So that's why, especially on the buses, especially on the buses. So in Delhi, for example, a couple of years back, there was a pilot project that had started. And as a part of this pilot project, there were certain buses that started running on HCNG. All right. They started running these buses on HCNG in a pilot, as a pilot project, just to understand the viability of HCNG, that how much HCNG is usable or not usable. So that's why we see this. And so overall, we see, and better performance due to high octane rating, meaning again we are talking about the same energy density, or in a manner the efficiency. So we do see that there are all these advantages that we get from HCNG, but there are certain problems. First and foremost, determining the most optimized ratio of hydrogen to natural gas is difficult. Although we have used it already, we used it in a way in which I think almost 20% mix of hydrogen versus CNG was done. So that's why, from that perspective, we see that um, uh, we already have used it, but we still are trying to find out what the most efficient way of mixing hydrogen and CNG is. So that is there. Then it requires new infrastructure for preparing HCNG. So that adds to the cost, right? It adds to the cost because you have to have new infrastructure so that you can start preparing HCNG. And then after that, there are many steps that are required to be taken for the commercialization at large scale. That as a pilot project, we have run it already. The project also has stopped. We are looking towards the studies and the findings of this pilot program, so that accordingly the future can be molded. The current cost of hydrogen is also problem, because obviously hydrogen is costly. Getting hydrogen, extracting hydrogen is not that easy. That's why we still are not using hydrogen as a fuel. Because if using hydrogen was easy, the extraction process was easy, we know that it's a clean source. No, there is no carbon dioxide, there is no sulfur dioxide, no particulate matter, no nothing whatsoever. So it's a very clean source. So if we could use it in a cost effective manner, we would already have been using it. So that's why today we see that whether India or the world, we are trying to find out ways in which hydrogen production can be optimized. Cost wise it can be optimized, but right now we know that current cost of hydrogen is a big challenge. And this also becomes a problem, because if let's say we want to run buses on HCNG, uh, we know that our cost of operation will be high. So cost of operation will be high, so either the government has to bear the loss and subsidize the rates, or then pass it, or the other way would be to pass it on to the consumer. But more or less they cannot pass it on to the consumer, because you have to understand that the people who are traveling on buses, they are opting for this public transport for a very simple reason, that it is very very cheap for them. All right, it's very very cheap for them, and that is why they are opting for a bus. That's something where a bus ride cost rupees, let's say 20 to 30. A ride on a cab in the similar route perhaps would have costed in the range of 200 to 250. So that is the reason why people are traveling on the buses, so that they can save a lot of money. Now you cannot go to them and say that, look, we are using HCNG, so that's why you have to pay more. Thinking about this sitting in a science or an environment class is fine, but in the practical world that does not work. And the people who are on the buses, they are on the bus for a reason. If I had an opportunity, if I could, I would travel on my own Mercedes, but I can't afford that. That's why I'm traveling on the bus. So that's why in these kind of cases we can't really increase the prices, and we have to understand all these aspects of the problems as well. Look at this question. This was asked in your paper. Please read the question. Meanwhile, I'm also launching the poll for you. All right. Please mark your answers. Hmm. So 24% of you have marked A, 46% B, 6% C, and 24% D. All right. So let's look at the question. In the context of proposals to use hydrogen enriched CNG or HCNG as fuel for buses in public transport, consider the following statement. So it is basically talking about the same thing. The question, when it was asked, it was still a proposal. Now this project has concluded. So look at the first statement. The first statement says the main advantage of the use of HCNG is the elimination of carbon monoxide emissions. This is a trap word. Do you remember what we had discussed some time back? This is an extreme word. It's not elimination. Elimination means that you are 100% reducing it. We discussed that it's reduction of carbon monoxide, and as I told you that almost by 40% we can reduce carbon monoxide emissions. Look at this, that it reduces the emission of carbon monoxide by approximately 40%, but your question says, or the statement says, that it is the elimination of carbon monoxide, right? So it's not elimination, it is basically reduction. So it's not elimination, it is reduction. So that's why one is wrong. So if one is wrong, A can't be your answer, D can't be your answer. So either 2 and 3 are correct or 4 is correct. So let's look at 4 first. 4 is HCNG makes the fuel less expensive than CNG. All right, less expensive. So will it make it less expensive? What we discussed is that the cost of hydrogen is more, so that's why HCNG is costlier than CNG. This is what we discussed here. The current cost of H2 is more than in natural gas, so that's why HCNG's cost is more than CNG. So here it says that HCNG makes the fuel less expensive than CNG, so that's wrong. So that's why we are left with 2 and 3 only. So 2 says HCNG as fuel reduces carbon dioxide and hydrocarbon emissions. Yes, it would. Using hydrogen, so you are using less of natural gas, so means that less of hydrocarbons or less of carbon dioxide. And hydrogen up to 1/5 by volume can be blended with CNG as fuel for buses. Now see, statement number 3 can be difficult. Statement number 3 can be difficult because you do not know, because these are the kinds of information that usually will be missed, and it's very very factual, so you might not know the answer. But you don't even have to get the answer from there. You get the answer from by eliminating the others. Today, if for example, let's say if the question was asked in 2023 prelims paper, they could have made it a nightmare for you by asking the new kind of question that they have started asking, that only one statement is correct, two of the statements given are correct, three of the statements given are correct. If this was the scenario, it would be a very very difficult question. But thankfully it came in an era when these kind of questions were not asked, so the elimination method used to work, and hence by elimination we could get to the answer to this question. In today's world, in today's examination pattern, they could have made this question a horror story for the students because of statement number 3 particularly. Others are still manageable, statement number 3 is very very difficult. All right. Yeah, so this is it about this part. So if you have any questions, so let's take a break here. I mean, it's 7:38. Today, Sarmat Mehraj sir will take a class from 8:30. I think it's 8:30 p.m. I don't think it's 8:30 a.m. So whatever questions you have, please post your questions as well, so that after the break, when we are back, I'll take your questions. So it's 7:38 a.m. So can we be back by 7:50? Okay. So let's take a break. And meanwhile, whatever questions you have, please keep posting your questions and we'll take all the questions at once. Welcome back, everyone. Let me first start with your questions, and then after that, we shall move forward. Difference between HCNG and CNG. Simple. You have extra hydrogen in HCNG, which you don't have in CNG. That's it. There's no other difference. And because of that extra hydrogen, what happens is that you have taken away some portion of CNG and you have added hydrogen instead. So it becomes cleaner, it becomes more efficient, lesser pollution, lesser impact on climate. So that's why all these things will happen because of that extra hydrogen that you have added. So you've taken away some portion of CNG and instead you have substituted it with hydrogen. That's it. Expandable launch system means in the care of GSLV. So it's not expandable, it is expendable. All right, expendable. So expendable means that something that can be used only once. So that's why we say that these all launch systems, these are expendable systems. So that's why that is what the context is. Core stage of launcher or launch vehicle. Core stage means the base, the lowermost stage, just below, you can say, or something that supports the first stage of the launcher is called as the core stage. What time class started? Class started at 6. We had a minor problem at around 6:10. Difference between normal and fractional distillation. So distance, the basic difference is that, see, both will be used for a very similar purpose, that when you have two fluids that mix completely in one another, to separate them out you would use distillation. But when the boiling point difference between all these fractions or all these components is very less, then normal distillation process can't be used. This is where you use fractional distillation. So in normal distillation you will directly heat up the mixture, and one by one the components will keep on boiling and converting into gaseous state, and you can collect it separately. Whereas in case of fractional distillation, you will first heat it to a temperature where everything is in gaseous state, and then you will start to cool it down slowly so that you start getting all the various components. So basic principally the difference will be that when the boiling point is sufficiently large, distillation can be used. When the boiling point difference is not sufficiently large, then fractional distillation. HCNG combines the advantages of hydrogen and methane. What does it mean? So it's simple. We are saying that because of HCNG or because of hydrogen being added, there is an added advantage. That until now, CNG, we know that CNG has its own advantages. For example, CNG is cleaner as compared to petrol or diesel. That's why we have been using CNG for such a long time in Delhi NCR region and now in other parts of the country as well. And with hydrogen being added to it, it will become much more advantageous. And why, we discussed about hydrogen separately as well. I'm unable to understand this question. What to do? I am from pure humanities background. See, very frankly telling you, a lot of things that we are discussing here, I'm very sure that even the science students have never heard of. All right, even for the science students, all these things that I'm discussing here, it will be new, because these are areas of current affairs. These are areas which are not typical areas of science, and that's why I'm discussing some of the basics of science related to these current affairs areas. So that's why just understand that it's not that you are at a disadvantage. Yes, I understand that it might have been some time that you might have left school or have read physics, chemistry, etc. You'll need an extra effort. I'm not discounting that, but just know this, that it's not that it's any kind of disadvantage. Just a little extra effort, you will understand everything very easily. If you have any doubt, just keep asking the questions and we'll keep solving your doubts and ensure that you are able to handle everything. So some of you have asked about what this 8:30 p.m. class by Samad sir is. I think this session, a brief session that he's taking, it's more to address some of the queries of the students regarding recordings and everything that many have raised. So those kind of, I think, areas are being addressed by him. Some of you, for example, yesterday also in the class you had mentioned, in my class, that you wanted that we extend this period of uh, uh, providing this before we start providing the 7-day buffer. So that's something that I also had a discussion with our uh, team yesterday, and they agreed to it that some of these things that they'll try to incorporate. So we are working towards all those solutions for all the concerns that you all have raised, and I think this session also is something related to the same. Mains questions, I'll have a discussion about the mains questions at the end of the module. I was planning that I'll do it on a Friday. So if not Friday, then on Monday I'll do a discussion on the first two chapters, and then after that subsequently the other chapters as well, one by one. So this is how we'll go here. I know it's little out of context, but I have this doubt about electric vehicles. Is this better option in terms of reducing emissions of greenhouse gases, or what is it? So see, Mahima, the problem here with electric vehicles, that I mean, as long as my opinion goes, as far as my opinion goes, I would say that it's a good medium term option for us, but it's not a good long term option for us. The reason is that even if when it comes to electric vehicles first of all also have to be charged, correct? Charging means using electricity. Electricity, if you are using electricity, largely right now is coal based. So if coal based electricity is used, ultimately indirectly you are still using coal. Yes, of course it is much better as an option as compared to petrol, or much better as an option compared to diesel or any kind of hydrocarbon based fuel or coal based fuel. But yet I'll still not say that it's a better option compared to, let's say, something like solar energy, or something like hydrogen, something like wind power, or biofuels. Compared to all these fuels or all these sources, I'll still not say that electric vehicles are a better option than that. But as compared to the fossil fuels, I'll still say that they are a good option. So in a medium term, let's say for the next 10 years or next 20, next 15, 20 years perhaps, electric vehicles can be said to be a good option. Why? Because at least for this medium term, till the time we are able to completely start depending upon all these sources like uh, solar energy or wind power or biofuels or even hydrogen for that matter, until the time we are there, electric vehicles is a good, for me, personal opinion, it's a good stopgap arrangement, because ultimately it's an electricity based vehicle and you are still using coal for a lot of these electricity based applications. So hence indirectly you are still using carbon. Difference between HCNG and CNG, I just told you. HCNG means that you have extra H, extra hydrogen. So some portion of CNG will be replaced with some extra hydrogen. That's it. It's sad that UPSC is checking our grammar skills too. I partially agree with you that a lot of questions are about wordplay. That if you understand the words well, you'll probably be able to answer the question. I'll not disagree with that. Natural gas is way more cleaner and cheaper than crude, so Why can't we replace crude oil with natural gas from Indian economy, as also suggested by energy minister in one of his interviews to a newspaper? So see, uh, when it comes to natural gas, yes, this is correct that it is much cleaner and cheaper than crude oil. But the problem with natural gas is that it's not easy to use. First and foremost, that the engines, you'll have to keep changing the engines, you'll have to completely move to a new set of engines. Wherever possible, we have done that. Natural gas also, many a times, in many a cases, you'll see that it is not able to generate as much power as the fossil fuels are. I mean, for example, petrol and diesel. That has been one of the reasons why CNG, although we started using CNG, but CNG penetration towards all the other vehicles has not been that great because of all these efficiency issues as well. Thirdly, it's still uh, it's a fossil fuel. I mean, still there will be emissions, although much lesser emissions, but still emissions will be there. So wherever possible, we are using, for example, LPG also, or even much cleaner source as compared to the normal cooking methods that we used to have in the past. And same goes for natural gas also, that natural gas, yes, it's a better source, but still the entire replacement is not that an easy job. And also natural gas availability is not that great as compared to petroleum. The processing of the fuel is also not that easy, and all these things also add up to the problems that we have. Electric vehicles do equal amount of pollution till it becomes final product? No. The amount of pollution is far lesser, much far lesser, but indirectly still some emission is happening. Difference between petrol and diesel. The basic difference between petrol and diesel uh, is largely based on the number of carbon atoms that you have in the hydrocarbon chains. So for example, when it comes to petrol, petrol generally has 5 to 9 5 to 9 carbon atoms in its chain, whereas when it comes to diesel, diesel largely has more than 12, 13 carbon atoms. So more number of carbon atoms also means that it is a thicker fuel. All right, the density is more, the viscosity is more, and the pollution levels are also higher. So that's why we see that diesel is more polluting as compared to petrol. So largely it is on the basis of the number of carbon atoms that you have in the mix. We discussed that Neptune and Uranus have high amounts of methane in their atmosphere. Does that mean there's very less or no oxygen for it to transform into carbon dioxide and water? Yes, in a manner you can say that, because when it comes to the atmospheric conditions that they have, you'll see that it is more of methane, and the oxidation that is required for oxidation of methane, you need oxygen. So there is an absence of oxygen, and because of absence of oxygen, we see that uh, there is absence of oxygen, oxidation is not possible, and hence we see that it cannot really uh, function. I mean, it cannot really transform into the kind of tropical conditions that we have here. Also, what we see is that in all these cases, also what we see is that in all these cases, even if, let's say, the oxidation had to happen, the temperature conditions are not suitable, because the temperature conditions are pretty low. I mean, you'll see that the temperatures, they can go way below the freezing point, and because of that, it's not that easy that you'll be able to do that oxidation. Even if, let's say, oxygen was present, even if oxygen was present, still it would not be easy,
because the temperatures are way below the freezing point, and that's why the oxidation process is not that easy, even if oxygen was present. But even, I mean, the oxygen is not present, so we can't really do anything. How do carburetor engines differ from MPFI engines? So basically, see, between these two things, when you come to a carbureted engine, what we see is that there is a central cylinder. All right, there is a central cylinder, and all this fuel goes into the central cylinder. And in case of MPFI cylinders, there, I mean, engines, there will be multiple cylinders, and the fuel will be injected to all these different cylinders one by one. So what happens is that overall, when it comes to and that's why it is called MPFI, means multi-point fuel injection, right? So what happens is that because it goes into all these engines separately, the efficiency of MPFI is better as compared to the central cylinder that you have in the carburetor engine. So that's the basic difference between the two. Not related to our discussion, but yes, this is what basically happens. Government is promoting green hydrogen. Where will it come in use? So green hydrogen basically in various different ways. I mean, we can use it in industries, we can use it in heavy industries, especially where a lot of carbon dioxide emission happens. Iron and steel industry, fertilizer industry, in all these cases, as a fuel we want to use it, as an electricity production option we want to use it. So there are multiple different ways where we can make the use of it. Right, so let's move on. Green hydrogen is where you get hydrogen by electrolysis of water. That you pass, I mean, very simply put, you pass electric current through water. It is able to separate hydrogen from oxygen, and you extract that hydrogen. So that is called as green hydrogen. Where do we study different diseases like dengue? So disease chapter will take later. I mean, as a chapter, disease will be a chapter that will discuss at a later stage, next week probably. Through hydrolysis, yes. So that is what green hydrogen is. Hmm. So let's move forward. The next source of energy, the next source of energy, we are, so now we have completed with all the conventional and all the non-renewable sources of energy. Now we move to the renewable source of energy. And the first renewable source of energy that we are discussing here is solar energy. Now, when it comes to solar energy, we understand that solar energy is one of the most important sources of energy for us. And why it becomes very important is that, first of all, it is a freely available source of energy. You don't depend on any country, you don't depend on anyone. So from that perspective, we see that solar energy is very crucial. Secondly, when it comes to India, partially, you know that India is a tropical country. So being tropical country also means that we have availability of sunlight much better than the countries which are in the temperate or the polar regions. So compared to that, we know that solar energy has a far better relevance for India as compared to the other parts of the world. So that's why solar energy becomes specially important for us, uh, especially important for India, because of the availability of solar radiation, because of the availability of solar energy in case of uh, India, because India is a tropical country. And that probably is the reason why this guy also landed in India, because this guy completely runs on solar energy and feeds on solar energy. And that's why a tropical country perhaps would have been better for him, as compared to, better for it compared to any other country. So that's why, very smartly, India was chosen. So anyway, jokes aside, when we look at solar energy, understand the importance of solar energy for India, because first and foremost, we know that it's a freely available source of energy. It is an energy source that, if we are able to tap, will become much more secured with regards to our energy requirements. That will not then depend on any country for petroleum or coal or for uranium, and all these kind of sources will be able to use that better. And that's why what we see is that India has been moving very aggressively when it comes to solar energy, and hence we have been able to use solar energy far more efficiently. And India has been among the fastest growing nations in the world when it comes to solar energy. If you look at the data, you'll find that India has been the fourth fastest growing country in the world when it comes to solar energy. So that's why we understand that solar energy becomes very, very crucial for us, given the fact that it's a freely available source. India is a tropical country, and hence we have been trying to tap into the solar energy as much as possible. Now, when it comes to solar energy, first and foremost, understand the targets that we have. So, first and foremost, right now, what we see is that solar energy in total, we are somewhere around 63 gigawatt. All right, we have reached somewhere around 63 gigawatt. Our target for 2022, the 2022 target was 100 gigawatt. So we wanted to reach 100 gigawatt of solar energy capacity by 2022, but unfortunately we could not. We tried our best. We have been very aggressive in terms of solar energy, but yet we could not, because it's a complex technology. It's not that easy to tap into solar energy. Otherwise, we wouldn't be using coal and petroleum. It was, if it was so easy to get energy from solar sources. So but we still see that 63.5 to be exact is where we were, and right now I think it's somewhere around 65, 66 gigawatt. So this quarter, I mean, we'll come to know about this quarter very soon, that what was the energy. So after, I mean, because June, July, August, so August end there will be a report that will be published. Just look out for that in the next 3 4 days. I think the next quarter, the previous quarter capacity will also be released by the government of India. So now 2022 target was 100 gigawatt. Going forward, we see that we want to be much more aggressive in this. We want to reach much higher heights with regards to solar energy. So that's why, especially when it comes to uh, the targets that India has kept, just understand two sets of targets. All right, the target, the renewable energy target, renewable energy target for 2022, and the renewable energy target for 2030. Understand these two targets. All right, the first target that India had for 2022 was 175 gigawatt, and the next target that we have is of 500 gigawatt. All right, the next target that we have is of 500 gigawatt by 2030. Now, what is the mix? Let's try to understand that as well. So in case of 175 gigawatt, the mix that we had was one, the targets were of solar energy, then for wind energy, then after that for biofuels. Solar energy basically 100 gigawatt out of this, wind energy 60 gigawatt out of this, biofuels 10 gigawatt out of it, and then small hydroelectricity, small hydroelectricity having a target of 5 gigawatt. This is the target that we had for 2022. Out of which, if I just give you the data of where we were, so for solar, we reached almost 63.5 gigawatt. In case of wind, we reached almost 42.5 gigawatt. Biofuel was where we exceeded the target. We were at 10.7 gigawatt. And small hydro, we almost reached the target. We were at 4.9 gigawatt. All right. So this is what we achieved out of the target that we had. Now, the next set of targets that we have, for 2030. All right, the 2030 target that we have is of 500 gigawatt. Now, in this time, when we are looking at this 500 gigawatt, the mix that we are looking is much wider. All right, what is the mix in this 500 gigawatt? First, again, we have solar energy, then again we have wind energy, of course, We again have biofuels. We again have a target of, will also use small hydro here as well. So these all that anyway were there. Apart from that, now we also have kept green hydrogen. All right, we have also kept green hydrogen. We also have included nuclear energy this time. We also have included nuclear energy in this mix. So nuclear energy also will be a part of the target. Green hydrogen will also be a part of the target. We also have now started looking towards geothermal energy. So geothermal energy, although we will not keep any specific target for geothermal energy, but we will try to tap into geothermal energy also, and we already have been trying to do that. So there will be all these different types of things that will be there in the mix of 500 gigawatt that we are targeting next. Whereas in the previous target that we had for 2022, there were only 4 parts that we were looking at. Now we see that we are going beyond this. We are widening, you can say we are widening our horizon now, and we are trying to look into all these different aspects also. So that's why from we see that these are the targets that we have. Now coming back to solar energy, which always will have the biggest chunk of the targets, that for example 100 gigawatt here, and this time we'll try to target more than 250 gigawatt out of this 500, which seems very very difficult to achieve, but yet we will definitely keep certain targets like this. Now now when it comes to solar energy, we see that solar energy can be used in 2 ways. Either we can use it as heat, or we can use it as light. All right, in both the ways we can make the use of solar energy. Now when we use it as heat, we call it as solar thermal. Thermal, always therm is the word for heat, so thermal means heat related. So that's why solar thermal means heat energy. And then we have solar photovoltaic. Solar photovoltaic. And again, understand, just break down the words and you'll get the meaning of these words. So when we say solar photovoltaic, what do we mean? So photo, the term photo is always associated with light, correct? And voltaic is related to electricity. Voltaic is related to electricity. So that's why we understand that when it comes to using the solar light or the solar radiations for electricity generation, it will be called as solar photovoltaic. And whereas when we say solar thermal, the term therm is associated with heat. So that's why solar thermal means it is where you are trying to use the heat of the sun for any application. For example, it's a solar cooker, solar water heater. In all these cases, you are utilizing heat of the sun so that you can use it in some form. Israel has a very unique power plant. Israel has a power plant which works on solar thermal. Generally speaking, what we see is that the electricity power plants are solar photovoltaic. For example, where we use solar panels for electricity generation. Whereas in case of Israel, they have a power plant where they have a very big unit where water is kept, and all the solar light that they get, it is concentrated towards that big storage of water. Now what happens is, because of that concentration of sunlight on the body of water, water gets heated. Water gets heated, converts into steam, and that steam will be used for electricity generation. So that in a manner you can say that uh, it's a manner in which they are using solar thermal energy for electricity generation, which is a unique kind of plant that Israel has. Otherwise, generally speaking, we see that solar photovoltaic is used for electricity generation. All right. So now when it comes to solar energy, so okay, Pratham, you have a very good question, but let me answer that later. Let's go through the topics first, and probably you'll get your answer while we discuss this, but anyway we'll discuss it later. All right. So coming to the first very very important equipment which is used in terms of solar energy, this is solar panel. Now in case of solar panel, just understand this, that solar panel is a device that will be used to convert solar energy into electricity, right? Solar energy into electricity. Now, in case of solar energy into electricity, how exactly solar panels work? Let's try to understand this. That first of all, we know that it is made of semiconductors like silicon, and when light strikes silicon semiconductor, it causes electrons to flow and thereby produce electricity. So this is how a solar panel works. Just understand the basic working pattern of a solar panel, that the solar photons, or you can say the particles from the radiation of the sun, they will strike the semiconductor. They'll strike the semiconductor that you have in this solar panel. Now, semiconductor is a very unique kind of a material. It's neither completely a conductor nor it is completely an insulator. It lies somewhere between a conductor and an insulator. Now, what happens in case of a normal conductor is that electrons are always ready. All right, electrons are always ready, and as soon as they get a chance, they will start the flow of charge, and hence electricity will be generated. But uh, electric current will basically pass through it. But when it comes to semiconductors, they're not always ready. Only in certain cases they will become ready, and one of these cases is striking of these light particles. All right, so what happens is that let's say you have a semiconductor like this. All right, let's say you have a semiconductor, and inside this semiconductor you have all these electrons. Now these all electrons right now, they are, or the charged particles, they are just randomly arranged. What then happens is that the solar photons or the sunlight, it strikes the semiconductor. All right, when it strikes the semiconductor, what we see is that in this semiconductor, now as soon as it strikes, what we see is that these all charged particles, they get arranged in a direction like this. All right, they'll get arranged in a certain direction, and now because of this arrangement, flow of charge inside this semiconductor would start. Flow of charge inside the semiconductor would start, and this will lead to electricity generation in this semiconductor. All right, so this is how the things work, and hence solar panel will now let the electricity pass through. Now this unidirectional flow of current is called as direct current. All right, the current that we produce here is called as direct current. So this unidirectional flow of current is called as direct current, and this direct current is something that can be used to store energy. It is something that can be used to store energy. So for example, if you want to store energy in the form of current, then uh, for example, let's say your mobile phone batteries, laptop batteries, any kind of battery that has stored electricity is called as direct current. So first we get direct current, but if we want to use it in our houses as a source of electricity, then direct current does not work there. We have to convert this direct current into something called as alternating current. So this direct current has to be converted into alternating current with the help of a device that is called as inverter. So you might have heard of inverter. Many of us have inverters at our homes. That whenever electricity supply is cut off, inverter would work and inverter would give you the electricity. How exactly does it do it? Because inverter has a big battery which is also there with this inverter. So what happens is that this battery has been storing electricity all day long. It has been charged. When you are charging it, you are storing electricity. As soon as electricity supply is cut off, when let's say for some reason there is a power cut, so wherever there is a power cut, this stored electricity now through the inverter will convert into alternating current, and hence will be able to light your houses. So this is basically what we see in terms of direct current and alternating current. So in this solar panel also, the current that first is produced is direct current. So either we can use that direct current to store electricity, if not, we can convert it into alternating current, and then after that it could either be sent to the grids or it can be used to light the houses. So in this manner we see that a solar panel would work. So essentially it is based on semiconductors, and in case of semiconductors, what happens is that when light strikes, they start a unidirectional flow of current, and then this is called as direct current. All right, so I'm just writing here, when solar photons strike the surface of semiconductor, electrons are arranged in a certain direction, leading to a unidirectional flow of charge, a unidirectional flow of charge, all right, called direct current, called direct current or DC. DC, so this is the first point. Second point, DC can store electricity or can be converted into AC for supplying electricity to homes through inverter. All right, so conversion happens with the help of an inverter. So this is basically what we do here. So the working of solar panel is something like this. Now, one more very important thing with regards to solar energy is the solar pump. In the last few years, what we have seen is that solar pump has also been promoted a lot by the government of India. The reason behind is simple, that right now what we see is that a lot of irrigation that happens in India, the irrigation is carried out with the help of some diesel pumps. Most of the times diesel pumps, some electric pumps. Now when it comes to diesel pump, obviously it has a lot of disadvantage for everyone. Diesel pump, for example, the farmer would have to buy diesel all the time, so they would have to keep spending money on buying diesel. So that is one problem. Second problem, so one problem for the farmer. Second problem for the government, that this diesel, the agricultural diesel, is subsidized. So government also loses a lot of revenue on this diesel because they have to subsidize it. The other diesel that is being used as a fuel in the vehicles, that is not subsidized. But in this case of agricultural diesel, it is subsidized. So government also loses revenue. So problem for the farmer because they have to keep buying this diesel, problem for the government because they have to subsidize it, and then also problem for the environment, of course, because it is diesel, so it is going to have a lot of air pollution associated with it. So to solve these problems, there is a new program, a new scheme that was launched in 2019, and this is PM Kusum Yojana. Now, this PM Kusum Yojana or PM Kusum scheme is a scheme where we are looking towards solarization of diesel-based electric pumps, or sorry, diesel-based irrigation pumps. So wherever we had diesel pumps, what the government of India is trying is that all these diesel pumps be replaced with solar pumps, and all these solar pumps are also being highly subsidized. Almost up to 75% subsidy is being provided on solar pump. And this, so let's say, if meaning that if solar pump costs rupees 100, then the farmer only has to pay rupees 25, rest rupees 75 will be shared between the center and the state. All right, so central government and the state government, they will share the 75 rupees cost, and only 25 rupees cost will have to be paid by the farmer if, let's say, the cost of solar pump is rupees 100. So that's why they are subsidizing it also, so that diesel pumps can be replaced with solar pumps in India. So overall, this is basically what we are going to see. So solar pumps, that's why they have become very, very crucial. So again, solar pumps can either be a DC pump or an AC pump, depending on what kind of electricity technology you are using. Most importantly, this classification is very, very important: submersible pump and surface pump. There are two ways in which solar pumps can work. Either it will be a submersible pump or it will be a surface pump. Now, in this scenario, when it comes to a submersible pump is a pump where the solar pump is kept inside the body of water. All right. So, for example, let's say if you have a tube well, any kind of well, or maybe a lake, or any, largely you can say any stagnant source of water. If you have any stagnant source of water, you'll see that in most of these cases, a submersible pump will be used. And this submersible pump, the pump will be inside the body of water, and from there on, it will try to uh, get the water, fetch the water for irrigation purposes. So that will be called as a submersible pump. On the other hand, we also have a surface pump. So in case of a surface pump, as the name suggests, surface, meaning that the solar pump is kept on the surface near the body of water. So largely what we see is that when you have a running source of water, in these kind of cases, surface pumps are used more as compared to the submersible pumps. All right, so these two pumping technologies are the most important classification of the pump, because depending on what is the source of water near that agricultural field, the farmer will either opt for a submersible pump or a surface pump, depending on that. So that this is the first classification, either submersible or the surface pump. So submersible pump will remain underwater, and surface pump is mounted on the top of the water, all right, top of the water body or the water source. Now, another way in which we classify the pumps is on the basis of centrifugal pump and positive displacement pump. So centrifugal pump. So when it comes to centrifugal pump, it is a pump that uses centrifugal force. All right. So when it comes to centrifugal force, what is the centrifugal force? The force that keeps on acting outward in a circular motion. So what happens in this kind of a scenario is, there will be a motor that will be in the body of water, and this motor will be rotating. So with the rotation of this motor, what we see is that it will keep throwing the water outward, correct? Because of the centrifugal force, this will keep on rotating, and while rotating, it will keep throwing water outward. So that water that is being thrown, that can be used. Done. Positive displacement pump. Positive displacement pump is, in very, let's say, trivial terms, it's like an injection. So in an injection, what do you see? That, let's say, the injection is inserted inside the bottle of vaccine. You'll see that when you pull the injection, the vaccine will also start to rise. Similarly, let's say if any kind of blood test, etc., is happening, you might see that if they are drawing the blood, uh, as they pull the piston of the injection, the blood is also drawn. So something similar happens with a positive displacement pump, that you will have a piston here. When you pull the piston, the water will also start to rise. Why does the water rise? Because the pressure difference that we create. Because of the pressure difference that is created there, we see that the water will start to rise here. So that kind of a pump is called as a positive displacement pump. So we see that there are these pumping technologies that are used, again depending on the body of water that is nearby. Depending on the kind of body of water that we have, you'll find that these kind of pumps or pumping technology would be used. So that is what we see with centrifugal pump and positive displacement pump. Now, most importantly, what we have seen is that there is a national solar mission. So as per the national solar mission, what we see is that the government had kept a target, that initially, as a part of the national solar mission, the target that we had was 20 gigawatt. And then after that, during the Paris climate summit of 2015, this 20 gigawatt target was revised to a target of 100 gigawatt. So initially the target was supposed to be just 20 gigawatt, and then the target was then revised to 100 gigawatt as a part of our pledge in the Paris Climate Summit, that we are going to contribute towards uh, um, solutions for global warming, and there will be nationally determined goals that every country would have, and India pledge that will try to increase our capacity of solar energy and the other renewable energy sources that we are using. So as a part of that national solar mission, we see that initially there was a target of deploying 20 gigawatt of grid connected solar power by 2022, which was revised to 100 gigawatt by in June 2015 as a part of the Paris Climate Summit. So in this manner, we see that this is something that happened. So now, as a part of National Solar Mission, we took various objectives. We took various missions. We took various programs, and all these programs and policies, they all became a part of this particular mission. So whether it is the PM Kusum Yojana, whether it is the Srishti scheme, whether it is uh, any other, for example, let's say when you look at the solar parks that we have been creating, whether it is about the grid connectivity that we have been increasing, uh, so in all these cases you'll see that solar city program is there, wind solar hybrid program is there. There are multiple different programs that we started, and all of them, they amount to this national solar mission, the basic objective being the deployment of 100 gigawatt of installed capacity by 2022. So this is basically something that became National Solar Mission. So as a part of the mission, long-term policy was taken, deployment goals were taken, aggressive research and development was done, and domestic production of critical raw material components and products were also started. And especially this fourth point, domestic production, is where we see that some controversy was also created, because initially, so what happened here is that initially you will see that India was importing a lot of solar panels from the US, other countries as well, but US was a big market for India. So India was importing a lot of solar panels from the US. But then we took the National Solar Mission. We had a much steeper target that we took, and with the steeper target we also realized that it's not easy for us to um, move ahead with the steep target depending on imports, because first of all the cost will be very high when you are importing and you are not producing. So obviously the cost will be very very high, and when you have such a steep target, you cannot be dependent on imports. So that's why the government thought that okay, fine, we'll not depend on these imports, we'll start domestic production of solar panels. And manufacturing of solar panels was made a part of Make in India project. All right, so the government of India decided now that we are going to start manufacturing solar panels in India. This did not go well with the US, because the domestic market of US was highly dependent on India for solar panel production. Now all of a sudden, if they lose a market like India, it also means that they are going to lose a lot of business as US economy. But at the same time, the internal job market or the internal employment opportunities in this sector will also go down. So that is the concern that US had, and US actually had dragged India to the WTO, that India all of a sudden cannot just stop buying solar panels from us, because our domestic market is going to be hampered, is going to be negatively impacted if India does so. India also basically explained its side, that why we are doing what we are doing, and essentially we were allowed that fine, we can gradually start our domestic production. And this is basically what we did, that we started our domestic production of solar panels, and over the years, over the past few years, we have been producing better solar panels. Initially the quality of solar panels was a concern, but we see that these kind of concerns now have been erased, and we have far better quality solar panels available in India, made in India in today's day. So all these have been some of the advantages that we see as a part of this national solar mission. Look at this question. This was asked in the context of the PM Kusum scheme. Simple question, something that we have just discussed. Please read the question, and then I'll launch the poll also for you. Please mark your answers. Hmm. So 68% of you have marked D, which is the correct answer. 10% A, 9% B, and 13% C. So let me discuss this with you. With reference to solar water pumps, consider the following statements. First, solar power can be used for running surface pumps and not for submersible pump. Why not? We just discussed that we can have surface pumps, we can have submersible pumps. Depends on the body of water. If you have stagnant body of water, you'll use submersible pump. If you have running body of water, you'll use surface pump. So we can use both will be connected to the solar panel. Just go back to this picture. See, both of them, they are connected to the solar panel. One connected to the solar panel and the pump is inside water, and one connected to the solar panel and the pump is outside water, but both can be used. So that's why. So not for submersible pump is wrong. Second statement, solar power can be used for running centrifugal pumps. We discussed, yes, we can. Not for the ones with pistons. Which are the ones with pistons? The positive displacement pumps, right? The positive displacement pumps, they basically are the ones with pistons. So we discussed that we can use both. So even this is not correct. So the second statement is also wrong. So correct answer here will be neither one nor two. So the thing is, see, I understand that in these kind of questions, many times what happens is that we by very nature are very positive species. So we think that at least one of the two statements should be correct. How is it possible that there are two whole statements given and everything is wrong? So we think that okay, fine, at least one of the two should be correct. So or maybe all of them should be correct, and many a times we lose track here. One thing that I also want to tell you here is that especially when it comes to prelims based questions, this is something that we do a lot. We try to guess whether it should be C or B, whether it should be D or A. That I have marked the last five answers as C, so the sixth answer should not be C, it should be A this time, or it should be D this time. So there's nothing like that. All right, there's nothing like that. It's not that UPSC is arranging a sequence, because if it was about arranging the statement, arranging the sequence, I probably would have been teaching you that instead of going through this entire set of lectures, right? I would be telling you about that more. So that's not the case. It's not that they arrange in a certain manner, but we many a times believe it. That I have marked six A's. How is it possible that the seventh one is also A? I'll ask you a counter question. How sure are you that the six A's that you marked were also correct A's? It could have been B or C, and you could have been wrong there, right? So that's why don't go by that logic that the previous answer was this or this answer is that and that answer is this. This can happen all the time in science. I mean, I'll tell you my own experience. 2020 paper, uh, most of the answers in science is D, all of the above or none of the above. Only these kind of answers questions have been asked. So even we at a time lost confidence that how is it possible that every answer that we are getting in the analysis is either either D, in one way or the other, all of the above or none of the above. So I understand that this can happen, but always remember that when you are solving a question, always solve the question on its merit, all the statements on their merit. So each and every statement is an independent statement, and take it independently instead of thinking about the pattern in your OMR sheet. Always remember that, right? Because we tend to do this, we tend to do it a lot. So but just be very objective in marking all these answers. In marking the objective answers, be very objective, right? So this is about this. Now there are certain things that have been doing are being done as uh, a new initiative, you can say. One of these initiatives has been solar tree. Now when it comes to solar tree is a structure that has a vertical setup, something like this. You have a vertical setup of solar panels instead of horizontal. One of the biggest challenges, one of the biggest challenges with solar energy is the installation of solar panels, because solar panels will be laid down horizontally on land, and many a times these are agricultural land. All right, many a times these are agricultural land, so we miss out on agricultural land because the farmers are being paid well for installation of solar panels, so farmers also let that happen. So what happens is that the farmer is getting their due, and it's not that farmer is at a loss, but the economy is in a loss because your production is going down. Production is going down because you are using the agricultural land for solar panel installation. So that's not correct, right? That's not entirely what we want to do. So this is where solar tree comes as a potential solution, that instead of horizontally laying down all the solar panels on the ground, you raise it on a platform and then you have the solar panel. And in this particular scenario also, it could be adjusted. All right, the angles could be adjusted depending on the solar intensity, depending on the direction of the sun. Even doing all these things are possible, that all these can be movable parts, and if these are movable parts, we can maximize the solar intensity on the solar panel and hence increase the production, not production, rather the efficiency. That what may happen is that from the same sunlight that you are getting all day long with the same set of solar panels which have been arranged in a fixed manner in horizontally, they might have lesser output as compared to these kind of scenarios where uh, these solar panels can move their direction depending on the directionality of the solar light. So that's why this kind of a setup that is called as a solar tree can do this. So this solar tree as a concept now also has been developed by CSIR, Center for Scientific and Industrial Research. So Council for Scientific and Industrial Research. So they basically have come out with this potential solution of solar tree, and they are claiming the kind of power that this solar tree will be able, or solar tree structure will be able to produce. Uh, uh, the efficiency will be, I mean, just to compare the data that CSIR has produced, what they say is that whatever energy we produce from a 2 kilometer square area with the help of solar tree will be equivalent to what we produce from a 20 kilometer square area in conventional power plants. So just imagine the kind of difference that they are talking about, the kind of impact that something like this can bring in. And we already see that there are many of the private companies also which are already working on these kind of potential solutions where movable solar panels are being worked upon, and these movable solar panels, they will change their direction with the change in the sunlight so that they can maximize the output. So already we see that all these things are already happening. So so CSIR has done it, many private companies are also doing it. So this is a positive direction in which already free source of energy, there also we are trying to optimize amount of energy that we can get. So when we look at the advantages, it reduces the land requirement, it becomes viable for both rural and urban areas, addresses the increasing demand for green energy, it is environmentally friendly, and it can also be helpful in increasing the farm income. Because what then happens is that right now, sorry, with horizontal installation, farmers are either getting their farm income, agricultural income, or they are getting the income from installation of these solar panels. What may happen is that in these kind of scenarios, they can uh, get financial benefits from both. They can use the ground as well, because now the ground has been freed up, and because the solar panels are being set up in their farmlands, they'll be paid some kind of compensation for that also. So that's why it will help in increasing the farm income also. So that's why we look at all these kind of advantages which are associated with solar tree. At the same time, when it comes to solar energy solutions, one more potential solution that India has been working on very aggressively is floating solar panels. Floating solar panels, last few years you'll see that a lot of installation of floating solar panels have been happening in India. Some installations have been done in Andhra Pradesh, some have been done in Kerala, some have been done in Chandigarh also, I think. And then there is one very very large plant which is being set up in Madhya Pradesh near Omkareshwar. This is supposed to be the largest floating solar power plant of the world. So that's why uh, it's a big leap that we are taking. In many states, one or two solar panels are being uh, floating solar panels are being set up. And floating solar panels, they come with their own set of benefits, because first of all, the problem of solar panel or the solar energy, the major problem has been that how it uses up a lot of land. So that also will be very very crucial for us from the perspective of the fact that we are not really going to uh, use up a lot of land. So that becomes one of the major advantages. So floating solar panels are where you have solar panels set up on the body of water. All right. So these are solar panels, solar panels on water bodies like lakes. All right. So the advantage that it will have, first of all, optimum land use. Then after that, what we see is that there is an improved efficiency also. And why improved efficiency? Because this is on body of water. All right, it is on body of water. So because water being there, there is a kind of a cooling effect that water body has. So the energy dissipation through heat that happens on land, that energy dissipation will not happen. So improved efficiency because of cooling effect of water, cooling effect of water. So that also becomes one of the advantages. And then after that, what we also say is that it's also important for the water bodies, because less evaporation will happen because some part of water is not exposed to sunlight directly. So that will also lead to reduced evaporation, and which will be better for, let's say, any water scarce regions, areas which have lesser water. For them it will be very very good. Then after that, what we see is that there are other aspects also. For example, let's say we can also think of how it can have an impact on the aquatic life as well. Now, impact on aquatic life basically can be seen in two ways. That one of the ways could be that there is a shading effect. So because of that, it will help in the growth of algae, and it will be able to maintain water quality as well. So that is one. Secondly, what can happen is that it can also lead to uh, problem with the aquatic ecosystem, because what happens is that you have blocked the sun, and when you have blocked the sun, there is no photosynthesis. So with no photosynthesis, the kind of growth that should have happened, that growth will not happen anymore, and hence you will start losing out on aquatic ecosystem. So that can also be one of the challenges that we have with floating solar plants. So just remember that when it comes to floating solar plants, we understand that today they are becoming very crucial, and India, again, the government of India has been trying a lot so that floating solar plants can be used. So looking at the advantages of solar energy, it is, you can say, in a manner self explanatory. uh, Renewable source, environmentally friendly, wide availability, versatile meaning that we can use in various form, we can use it in various forms. Low noise, I mean, for example, let's say when you talk about thermal power plants, we know that there is a lot of machinery and movement and all that, which is not there in solar energy. So that's why no noise problem. The maintenance requirements are low. It can become very easily a remote and portable power solution that you can very easily install it anywhere, and you're not dependent on a connection coming from a wind farm or coming from, let's say, a thermal electricity power plant, etc., the return on investment is very good because it can be maintained for a very long time. Solar panels usually can last up to, you can say, almost up to 15 years of time. Then increase energy security. What do we mean by energy security? Energy security is where, you see, when we say that we have ample amount of energy available to cater to the needs of the country. Right now, energy security is a big challenge for India because for all our petroleum needs, for example, we are completely dependent on foreign countries. We are dependent on the West Asian countries, on Europe, on Russia, on other countries. So that's why we have to maintain good relations with everyone, because we know that we cannot afford to lose uh, some kind of commercial benefits that we have right now from these countries. So that's why energy security, because of that, we also have to compromise on international relations many a times. For example, let's say in 2016, when US had imposed sanctions on Iran, it also asked India not to buy oil from Iran. It asked India not to buy oil from Iran. That point of time, if you look at the data, you'll find that Iran was the second highest exporter of oil to India. So overnight, we cannot uh, ask Iran to stop sending us oil, because it's not Iran who needs the oil, it's us. Iran will get a new market. If Indian market goes, they'll get a new market and they'll start selling it there. But what will we do? We cannot lose out on the second highest. All right, we cannot use on out on the second highest import country. So that's why we had to maintain good relations with India, with Iran. At the same time, we cannot have bad relations with US as well, because we have so much of commerce happening with the Europe, sorry, with the US. So because of that, we are in a position and we have to strike a fine balance. So these are the issues that we often get. Then it's an involving technology. We see that there are a lot new things happening, a lot of innovations happening. That's why a lot of startups, etc., also coming in this picture. So there are so many things that are happening, and it leads to a lot of employment generation, right? Because of the new companies or whatever, even government initiatives are being taken, all these areas, we see the advantages of solar energy. The disadvantages, first of all, it is expensive, at least initially. So at least initially it is expensive, and later on, as we discussed, that the return on investment is very good. Then it becomes a day night only solution, because at night obviously you don't have any sun, so there is no sunlight, and there is no sunlight, so there is no solar power production. Then it is vulnerable to atmospheric conditions. So atmospheric conditions like, let's say, rainy season or cloudy weather, this will block the sun, and when it blocks the sun, obviously solar radiations are less on the solar panels, and hence the production will be very low. At the same time, even air pollution is a factor, because air pollution also, for example, in North India, especially in Delhi, Haryana, Western Uttar Pradesh, that region, we see that there is a dense smog condition that prevails in the month of December and January. So in these months, sunlight is blocked, or even due to fog in winter, sunlight will be blocked, and you'll not get any sunlight for the operation of these, uh, anything related to solar panels. Then it has a large footprint. Basically, we are talking about the land requirements, what we discussed as one of the key challenges. And then there is a small amount of manufacturing pollution, manufacturing of solar panels, manufacturing of other components. So their electricity is being used there, some emissions also happen, but this emission is nowhere comparable to what emission is being done by being done by fossil fuels today. All right, so compared to these fossil fuels, this pollution is nothing. All right, this pollution is nothing, and we don't need to care about, we don't need to be afraid about this manufacturing pollution. So this is pollution associated with manufacturing of solar panels and other critical components. All right, manufacturing of solar panels and other critical components. So there we see that some of the pollutants like carbon dioxide, etc., are emitted. Now coming to wind energy. Now wind energy is the kind of energy that we try to harness through these kind of windmills, where you have the fans which keep on rotating, and with the rotation of the fan we produce kinetic energy here, and this kinetic energy can be converted into electricity. So this is basically what we do in wind energy. Now first and foremost, when it comes to wind energy, what do we mean by wind? If I ask you a very simple one line definition of wind, how do you define wind? I'm talking about class 5 6 geography. Yes, Himanshu correct, Chaitanya correct, Mahima correct, Pratham correct. So understand this, moving air is called wind, right? Very simple definition that we learned in very lower classes. We say that moving air is called as wind. Now, the better definition would be that it is a kind of kinetic energy associated with the movement of large masses of air caused by differential heating of the atmosphere by the sun, irregularities on the surface of the earth, and the rotation of the earth. And overall, Earth's terrain, body of water, and vegetation cover, etc., can also uh, can also be modified. Wind flow can be modified by these factors as well. So overall, when we look at wind, we understand that wind is nothing but movement of air. And if we have a fine movement of air, then this basically can be used to harness wind energy. Now, when it comes to wind energy targets, what we discussed is that target for 2022 was 60 gigawatt, out of which we were able to reach approximately up to 42.5 gigawatt, which is also a very significant number, a good number. Again, in terms of growth, what we see is that in terms of wind energy, also, India is again the fourth fastest growing nation in the world. So that's why we have been moving very fast towards it. If you look at the previous data, you'll see that in 2017, India was the fastest growing nation. India added the most capacity of wind energy in the world, more than any other country in the world. And still, right now, also, we are the top four nations when it comes to wind energy capacity addition. So, overall, with wind energy, we do understand that wind movement can be used to harness energy. Now, when we look at India, the states where wind movement is better are of course the coastal states, correct? And that's why when you look at the top 5 wind energy producing states in the country, we start with Tamil Nadu, then we have Gujarat, Maharashtra, Karnataka, and then you have Rajasthan. And of course Rajasthan also, because of the desert area being there, there are wide open spaces available for the movement of air or the wind movement to happen. And hence the top 4 states are the coastal states, and the fifth state is Rajasthan, which is a desert state. And it's easily understandable why, because coastal states, whether it is coastal states or the desert state, these are areas which are very wide open spaces, and hence they do not hinder the movement of air. So that's why these are the areas or these are the states that can be important. So what happens here is very simple, that first and foremost we'll see that the rotation of the windmills will happen, of these fans will happen, and then it will be passed on to the transformer, and transformation increases the voltage for the transmission to happen. And then after that we see that from here on it will go to the substation, and long distances the transmission grids it will pass through. So from there on it can be, the energy can be provided. So overall wind energy, we see that wind energy has been one of our top priorities, and we know how to harness energy from here. Now in case of wind energy especially, so what we know is basically that kinetic energy kinetic energy is being converted into electricity. Kinetic energy is converted into electricity. So this is basically what is happening in terms of wind energy. Now, in case of wind energy, there is one more topic which is important, and this is about offshore wind power. So today, what we see is that there is a new world of wind energy towards which we are trying to move, and that is the world of offshore wind energy. Now, when we say offshore wind, the meaning of offshore wind is that these are wind energy or wind farms which have been constructed on bodies of water, usually in the ocean in the continental shelf, to harvest wind energy to generate electricity. Now, right now, with regards to offshore wind, it's pretty new as compared to, uh, as especially compared to the conventional onshore wind energy power plants. So right now, what we see is the end of the 2022 report says that right now the world capacity is 63.2 gigawatt. So it's not that, I mean, in case of onshore wind, we are saying that only India has 42.5. Here we are saying that the entire world combined has 63.2 gigawatt. Out of which also what we see is that largely it has been European countries which have led the way of offshore wind power. But then recently we have seen that China also has been moving very fast. China has been adding uh, a lot of capacity, of offshore wind, and very soon I'm very sure that China will become the leading nation the way they are moving. Not only in their coastlines, even in the controversial waters, they are using that. So, for example, 2 3 days earlier, also you might have seen that there was a controversial map uh, released by China, where very easily, very casually, they have just included Arunachal Pradesh and Aksai Chin, etc., these areas also as a part of their map. So they don't even care that these are areas, of course, that belong to India and they don't belong to them, but they don't care. Taiwan has been included in that map. Parts of South China Sea has been claimed. So in all these areas, China has just claimed it. For China, entire world is China. I mean, they don't bother about boundaries. The boundaries do not matter to them. They already have captured Tibet. We know about that. We already know about what's happening with Taiwan as well. We know how they have been trying to enter the Indian boundaries as well. The Aksai Chin area already is something that they have captured. They have been claiming Arunachal Pradesh also. They have been causing issues in our Sikkim borders as well. So unfortunate the way they function. I don't know what they want, but the way they function is pretty problematic, and especially for us being a neighbor. If we were a European country, probably we could also have talked about the problems of the third world countries, but unfortunately we are a part of it. Unfortunately, we have two neighboring nations in China and Pakistan. I don't need to tell you the problems. So, so that also, I mean, you know about international relations, and probably you'll study much more about relations about these issues. But whether internationally or even internal security issues that these countries create. So that way, just imagine a scenario where India is a part of some of the European countries and lies in the midst of the Nordic countries or somewhere there. The country will be very different. Our economies would be very different. The kinds of problems that we keep talking about and the indices that are released very often, putting India somewhere in the middle or down, those kind of issues would never happen if we were not surrounded by these countries. But what to do? Atal Bihari Vajpayee, our former prime minister, once had said that you can choose your friends, but you cannot choose your neighbors. So we have to live in with our neighbors, and we have to find out ways in which we can live with our neighbors. So anyway, not going off topic so much. Offshore wind. What we see today is that offshore wind energy capacity is being added by all the countries. European countries led the way. Today, we see that it is China that is leading the way much more aggressively as compared to any other country in the world. And very soon, they will become the leading nation with offshore wind. When it comes to India, we see that India also has been working on its own offshore wind capacity. We now have a national offshore wind capacity policy and wind power policy. And through the with the help of this policy, we are finding out ways in which we can also start harnessing offshore wind. So right now, what we see is that there are certain challenges that India faces while harnessing offshore wind. that first of all, a lot of data collection is required, right? Lot of data collection is required. And now, in what terms data collection? Data collection in terms of whether the area that you're choosing, is it viable area? This should not be an area that is frequently visited by cyclones or other natural calamities. Also, the seismic stability of that area has to be taken into account. The wind movement, the direction of the wind movement also has to be taken into account. And you don't have to do just the past and the present research, but you also have to do a future research, because you are not going to install that wind power plant just for, let's say, the next year or the next 2 years. You probably will want that it is functional for 10, 15, 20 years or so. So that's why you'll have to collect data. You'll have to ensure that over the next 20 years also nothing will happen, right? You'll have to ensure that over the next 20 years also nothing happens. It is such a stable area. So that's why a lot of data collection, a lot of study, a lot of research and development is required before we can use any one of these wind power plants. So that's why a lot of investment is required. Then again, when you look at Europe, we see that a lot of offshore wind energy was supported over by years of incentives. A lot of incentives being provided to any company that is working here. Now in India, there is no such incentive right now. We have just started working, and that too, government has started working. The private companies are not working. And the private companies won't jump in here. One difference between, let's say, when you talk about solar energy or also onshore wind, you will see that there are startups that are working in these fields. But the same startups wouldn't want to work in offshore, because offshore needs a lot of money, it needs a lot of investment, and you may not get any positive revenue out of it for a very long time. So only countries which can manage those losses, the bigger companies which have so much of money available with them that they can spend and forget about that money, only those companies can manage, otherwise not. So unless the government subsidizes it a lot or provides a lot of financial support, it will not happen. So that's missing right now in the Indian context. Thirdly, one more thing, a basic practical thing, that right now production of solar energy is cheap, and the growth of wind energy, the onshore wind energy, is still in its movement. So it's not that we have settled with our solar energy and wind energy capacities. We are spending a lot of money there. We are uh, spending a lot, I mean, we are putting a lot of effort there. And because of all these things, we see that it actually becomes something where we see that solar and wind energy or onshore wind energy has been our primary go-to sources, and offshore is just starting. Now with offshore, what we have seen now is that Indian government has started to make some efforts. So for example, there is one pilot project now that we are starting with, and this pilot project is going to be the first offshore wind power plant in being installed in Gujarat. Two states have been chosen. One is Gujarat and one is Tamil Nadu. So these are the two states that have been chosen, and these two states have been seen to be the most conducive for offshore wind power generation. And that is the reason why we see that these two states have been chosen. And apart from that, what we also see is that we also have been approaching some of the European countries which have been using offshore wind for quite some time. For example, the government of India now has signed an agreement with Denmark, with the government of Denmark, and Denmark is going to help India in installing these offshore wind power plants, because Denmark has been one of those countries which has good knowledge and experience with offshore wind. So that's why we have an agreement now with the government of Denmark, so that they can help us in uh, installing these offshore wind power plants. So overall, when we look at wind energy advantages, again, most of these advantages are self-explanatory, that it is a renewable and sustainable source, environmentally friendly, reduces fossil fuel consumption, it is a freely available source, small footprint, unlike solar energy, because it's a vertical installation. Then it can be used for both industrial and domestic installations for both. It can also become a remote power solution. Wherever you have good wind speeds, you can install for the local requirements. Then maintenance requirements are low, energy security and employment generation. So the same, more or less you can say the same advantages that we discussed with solar energy as well. Now overall, when we look at disadvantages, there are certain points that we need to understand. First and foremost, the problem is the fluctuation of wind. See, when it comes to wind energy, remember that we need a minimum of 15 kilometers per hour. The minimum speed requirement is 15 kilometers per hour. And another requirement is that generally speaking, the installations that are done at 100 meters, at least 100 meters height above the ground. So these two conditions are required. All right, these two conditions are required for wind energy generation to be optimum, to be advantageous. But fluctuation of wind will always happen. You cannot guarantee a seamless flow of wind. It is determined by a lot of factors. So that's why we see that fluctuation of wind can be one of the problems. Then initially it is expensive. Although here also our return on investment is good. Here also return on investment is good. That is, in a long term, it's very good. But when we look at the short term thing, we understand that it is something that can be uh, something that can be expensive for us. All right. Then apart from that, one more thing that we see is that overall when it comes to wind energy, noise pollution is also a factor. That because of the movement of the fans there will be noise, so people locally living in these areas, it can be a menace. Then there is something called as visual pollution. So visual pollution is whenever you have any artificial structure, artificial structure in natural setup. This will be called as visual pollution. So for example, let's say when in a very clean area, a natural area, maybe a coastline, maybe somewhere in the forested area, you have installed a wind farm. So that's visual pollution. So it is not the kind of pollution like air, water, land pollution, etc., but just the aesthetics of the area. So for example, when you think that I'll construct my home in the midst of the forest, so constructing the home midst of the forest means that you have destroyed the natural beauty of that area or the aesthetics of that area. So that's visual pollution. So you might like it, but the nature does not. So that's basically called as visual pollution. Now, out of all these things, the major problem, one of the biggest challenges here is the threat to wildlife. The threat to wildlife that wind energy uh, leads to. So understand the problem. First, look at this picture. All right. So what you see is that you have a big wind farm or the fans, and you have so many birds which are flying here. So for the birds, it can be a menace because once the rotation of these fans start, for the movement of the birds to happen, it will be a danger. So that's why the birds will also realize this, that it can be a threat to their life if they come in contact with these rotating fans. So they will try to avoid that area. All right, they'll try to avoid that area. Now avoiding that area also means that what may happen is that the natural flying that is required for, let's say, for collection or even for breeding purposes, or the niche that they have there in that given area or in that given habitat, that niche will be destroyed. And because of that, they perhaps will start considering moving to a new area or moving to a new habitat. Now moving to a new habitat is not that easy because you would already have somebody else who is filling the shoes of this bird somewhere else in another ecosystem. So you cannot simply just go there and become the part of that ecosystem. It will not be easy for that bird to do that. Also, you have a working food chain, you have a working food web, and this bird would have been a part of that working food web, and all of a sudden that bird is removed. So it's not only this bird that suffers while trying to find a new habitat, trying to find a new ecosystem, but also this food web, that was where this bird was a key part of that web. So even the other organisms that were dependent on this bird, even they will suffer a negative consequence. So that's why this is a big challenge for the birds, right? So that's why this, just understand this, that why are we talking about the threat to wildlife? Why are we talking about the threat to wildlife? So what happens is that the movement of birds is restricted, meaning they may have to find new habitat which will have a negative impact on this bird and other organisms dependent on this bird. All right. So this is one problem. Now, one more problem that we see, and this is in the context of India, and comes to when it comes to in India, we have something called as environmental impact assessment. Have you heard of it? Environmental impact assessment, EIA. Do you know what it is? So, okay, some of you don't know. Anyway, so see, what happens is that in case of environmental impact assessment, these are rules that we have in India. And as a part of this rule, environmental impact assessment rules, uh, for any kind of big project, any infrastructure project, any new project being taken in any area, or especially in ecologically sensitive areas, there is an impact assessment that will be done first, understanding that whether there is any negative impact that the environment will face because of this new project or not. We'll do a proper comprehensive analysis first, and if we see that there is no problematic issues that we have here, we'll move forward with it. And if there are issues that it can have, if these are big problems that it can cause to a given ecosystem, the clearance to those kind of projects might not be given. All right. Now, as per the EIA rules of India, any renewable energy source is exempted. All right. Any renewable energy source is exempted. So, for example, let's say if you are building a solar power plant somewhere, a big solar power plant somewhere, it is exempted. Same goes for wind energy also, because these are renewable sources. So, EIA in India, what we see is that renewable energy sources are exempted. So what the problem is? The problem is that even if they would have had a negative impact on the ecosystem, it doesn't matter, because we are considering that it is already a clean source of energy, or it is a green source of energy, renewable source of energy. So it is being uh, excluded out of the EIA rules. Now, the problem here is that it may have a negative impact. That one thing about the birds in general. Then there are certain specific cases that we have seen, that because wind generation is obviously happening from here, so there will be high power transmission lines that will be running from these areas. There have been instances where the birds have gotten electrocuted and they have died because they got in contact with these high power transmission lines. And some of these birds, they are critically endangered species. One of the examples is right here. Do you know which bird it is? Yes, the great Indian bustard. This is the great Indian bustard. Now, the thing with great Indian bustard is that very few of these birds are left in the world. And forget about the world. In the world, they are now only found in India. There was a time they were also found in Pakistan, also in Nepal, in all these countries as well. Now in Pakistan they are gone, in Nepal they are gone, Only in India they are left, and that too there are only few states: Rajasthan, Gujarat, Maharashtra. These are three states where you actually find the great Indian bustards. Now, the numbers are also very small. I mean, do you know how many great Indian bustards we have? Do you know how many great Indian bustards we have? Yeah, so number is less than 150 now. So overall, what we see is that we have the Desert National Park in Rajasthan, where we are conserving these species in there. Uh, the protected area, I think, almost 90 of them are found in uh, there. So Desert National Park. So just, I mean, I don't know. I'm going little beyond our requirement, but one is Desert National Park. Desert National Park, and one also, remember, you have the Ramdevra Army Protected Area. Ramdevra Army Protected Area. So uh, these are, so one is this and two is this. So these are two areas where we are protecting great Indian bustards. So almost 90 of them are found there, and then apart from that there are others in the wild. So there have been instances where there has been an instance where a great Indian bustard died because of this electrocution. So now you have to understand the context that a critically endangered bird lost its life because of wind energy. So it's nothing against wind energy, but there are certain policy changes perhaps that we need as a part of our system going further if we want to protect the wildlife from this perspective. So that's why I understand that threat to wildlife has been one of the talking points when it comes to the disadvantages that wind energy has. All right. So this is about wind energy. Next is geothermal energy. Let's start with geothermal energy tomorrow. So tomorrow we'll have a discussion on geothermal energy first, then we'll move on to biofuels or bioenergy, and towards the end of the session tomorrow, perhaps we'll be able to start with nuclear energy as the last part of our discussion in this chapter. So meanwhile, if you have any doubts, please let me know. Let's have a discussion on it, and then we shall end the session for today. There was a proposal for sanctuary for great Indian bustard in my district in Maharashtra, but it got a lot of resistance. Yeah, locally that happens a lot of times, uh, but sometimes we have to understand that how exactly we need to save these birds. But what we have seen is that even if there is no sanctuary, uh, especially, I mean, this is something that we have observed in these three states, that the local community also has been protecting these birds a lot, that they have been mindful of the fact that this is a bird that needs protection, and thankfully so that they have been doing it. What is wind fluctuates? Wind fluctuation meaning that there is a change in speed, that sometimes the wind speed will be very low. So with very low wind speed we cannot really function. We, as I have mentioned here, that we at least need 15 kilometers per hour speed. Will the solar panels not have an impact on birds? Not really, I don't think so. Disposing solar panels is also an issue. Yes, disposing solar panels is a big challenge. Oh, let me write it here. It's actually a very important point. One of the major problems here is the e-waste, all right, or the electronic waste that we generate here. Because solar panels, see, solar panels will have semiconductors, they will have glasses, they will have plastic. So they will have uh, glass, they will have plastic, and then there will be the semiconductor. All right. So because of all these things that we have here, we also need to understand the problem, because right now we are just growing with solar energy, and in general the solar panels have a life cycle of 10 to 15 years. So now that the growth only has happened in the past 5 6 years more than ever, we'll start facing these issues in the next 5 years. So then it will start becoming a menace if we don't have proper waste management rules for solar panels as well. So yes, it's a very very crucial point. Are realistic targets better or ambitious, better than ambitious ones? So Pratham, you had this question. So see, one thing that we need to understand here, that whether it's an ambitious target or whether it is a realistic target, how well equipped are we to reach those targets? That many a times what happens is that we see that okay, practically this much is possible, so let's not go beyond that. So what happens is that, I mean, more often than not you don't reach those targets. That if, let's say for example, Indian government had a target, a continued target of 20 gigawatt instead of having a 100 gigawatt target, we perhaps would have reached 20, but I'm sure that we would have not reached beyond 25, 30, because our goal was 20 and we would be relaxed once we had reached 20. But because we had such a steep target of 100, and we have not reached the targets of course, but at least we could get to up to 65. I think the latest, the last quarter report I think was 65 point something. So at least we reach that far. But the target should not be so unrealistic that you are not going to get anywhere. So for example, the same part of the national solar mission, there is a sub part of this mission called as the Srishti scheme. So according to Srishti scheme, 40 gigawatt of this solar energy was supposed to come from rooftop connected solar power. Now, in rooftop connected solar power, India has no experience, no prior experience. It's very new for us. So now what happens is that we started building it, we started building the infrastructure for it, but we could not reach the targets. We could not even reach 25% of the targets. Out of 40, the target that was, I think we reached somewhere around 11, 12 only, and rest of the ones are still coming from grid connected where we have a good experience. So that's why taking having ambitious targets is not a bad idea, but depends on whether you can achieve it or whether can you reach even uh, a big good distance there. According to COP26, India has target of 500. Yeah, that is what we basically discussed. Leaderboard, some of you have asked for. Let me display the leaderboard for today. Yeah, so this is it. Oh wow, so many rank ones. That's great to see. I think those fans will also disturb the wind direction. Not really, because that's a very little small part of it. It is known as Maldhok in Maharashtra. Okay. Solar power plants in Rajasthan may also result in de-desertification on Rajasthan. Is greener Rajasthan more preferred or the deserted one? See, changing the ecosystem is never thought to be a good idea, because it's a part of a very large ecosystem that the earth has been maintaining on its own and has been running naturally on its own. So uh, that's why you have to realize that changing an ecosystem is never a good idea, because the kind of wind flows that happen, they would be altered. They would have an impact on the monsoons as well. So then the rainfall in India, in other parts of the country, will also be affected. So that will have an indirect impact on your agriculture. So there are a lot of impact. There will be a cascading effect that something like this could have. So that's why I believe, and whatever I have read, uh, changing an ecosystem is never a good idea. For example, many of the West Asian countries have been trying to do that, or Egypt has been trying to do that. So Western Saharan countries, African countries have been trying to do that. Not a good idea, I believe. And there are a lot of negative repercussions that something like this could have. Right. So this is the leaderboard. So many rank ones, so many sweets for me today. How many questions from science in prelims and mains? Usually we see that there are 12 to 15 questions in prelims and 3 to 4 questions in mains. All right. So I think I've answered most of the questions. If you have further questions, you can always reach us. So let's end the session here today. Please go back, revise everything that we discussed. A lot of data, etc., also has been discussed today. So that will help you if you just go back and revise everything once again. Tomorrow, when we are back, we'll start discussing geothermal energy, then biofuels, and then nuclear energy. This is what we are going to discuss in tomorrow's class. Thank you.